I got you covered. I got you covered. Things are a bit messy. I was working on the RC car. I raced it around a little bit and then crashed it a little bit. And so it has exploded, and I'm just now getting it back together. Luckily, this time, all of the air handling equipment, all the spoilers on this thing actually made a difference. And there's a brief little video on the Discord where I'm trying to film and drive at the same time. I need to make a little mount for my phone that goes onto the controller, but this thing is crazy. I had no idea. The Arrow is actually doing something on this. Believe it or not, having all of these little baffles that are hard to see on the camera right now, but having these little baffles that go up are actually pushing air upwards and pushing this thing against the ground. So when I reach the crazy super turbo mode speeds, this thing tends to slide out a little bit less. Of course, the super soft rubber was a bad idea. These mini Z wheels, the rubber on this thing, I think this is like 20 degrees bricks or something like that. The ones that I was trying to use are 10 and 5 degrees bricks, and when you really hammer the throttle with them, they actually just fly off of the hubs. My double-sided tape wasn't enough to hold them on. I mean, really, you shouldn't be going that fast with this thing because usually you're racing this thing indoors and on a track that's not that big. But I've got this motor in here that can go crazy super fast, and so we'll take advantage of it eventually. I'm looking at the electronics before I race it again, because ooh, wow, that needs, hold on. Let's do that. Let's just calibrate that real quick. And it's back. For the calibration, I actually have it lower the brightness significantly just so that I can tell that something is happening. But yeah, the electronics, what I'm doing is I'm putting connectors on it that have strain relief. So they've got something that's holding on to the jacket of the wire this time. Really, I should put like sockets on this, but I don't have room for it on this particular setup. The DOS Micro stuff just gives you a pad and says good luck. So instead of just soldering wire directly down, I'm actually putting something that is at least gripping that the jacket of the wire a little bit. I could also probably get away with using like UV epoxy to hold it. That would work too, but I'm trying this method out. I probably should use these as connectors, but I think I'm gonna solder these from underneath, and that way I'll have the connections under that this will sit on top of, and then that'll go to the servo right there. So I need to solder all this stuff up, and probably use a significant or a consistent wire size for everything. I think I can get away with using this stuff for everything, but I only have so much of this wire. This wire comes from other speed controllers, and it's thinner than anything that I have here. So if I use the thin stuff and then I crimp ends on it and then solder the crimped ends onto pins, then that'll hold my wires and they won't, you know, when this thing crashes, it pretty much just throws all this stuff out into the atmosphere. And so I'll probably do like a dollop of UV epoxy on like certain edges, because this actually screws down to hold down the steering mechanism. Oh, and I put a connector down there too. But that screws on to hold that steering mechanism. So I don't know, having them all on plugs and having wiring harnesses that I can plug and unplug, probably a good idea considering like this stuff could break, but I don't know if I'm going to be able to afford that. I don't have enough tiny little 3-pin connectors. I think this is the only one that I have. So these are Hyros, the DF13 series, which I have lots of because I've used them in other projects. They're nice and small. They're good for drones. They're very hard to crimp though. Like, could I put a 5-pin socket on the radio? I don't think I can. I could put it on a pigtail on the radio, but I don't want to get into that. RC car, like with RC cars sometimes see water, right? You're racing it around, you hit a puddle and everything gets wet, which would kill this particular electronic setup. Typically in an RC car, you have stuff that's in enclosures. You sometimes shrink wrap your electronics. You know, it's like drones. They got to be environmentally sound. But for me, I'm just putting them into a little electronics holder. So I don't know. Wonder if I could like professionally race the car. Not really professionally, but like, you know, enter an actual race. We're going to get to Node Red. We're going to get to Node Red, and we're going to get to burn the subs. In one in the same, right? So the fart box is sitting right over here. It's sitting right in my view. I have been looking into the Node-RED pub/sub Twitch stuff, and I have to register a robot, and in order to do all that stuff, that means opening my Node-RED to the wider internet. And that means that I need more authentication, more obnoxious stuff that I have to do with Node-RED, like keeping it sterile for outside connections so that people don't come in and, you know, register things against my will. Do stuff against my will. Hey, I was going to look at this. This is probably not the right size. I see controller boards completely covered in epoxy potting. Very annoying if you want to figure out what chips they use. Well, the thing about, yeah, potting is wonderful in terms of environmentally protecting a system that you know works. But if you ever need to work on that system, you're in trouble. I've dealt with a lot of potted circuits. There's only so many ways that you can have stuff survive the desert. But I was, for this at least, I would use ultraviolet epoxy. That pin pitch is very similar. That's a very similar pin pitch. That's interesting. I guess I could have a 4-pin. Do we have a 4-pin socket? We do. I could do a 4-pin and 3-pin socket and then make 2 plugins for the back of the radio module. Yeah, there's rubber potting. I know Vicor, the power supply module, they use this pink silicon rubber potting, and that stuff doesn't really stick to the electronics. It just kind of gets into everything. I'm just talking about ultraviolet epoxy, and ultraviolet epoxy will just give up the ghost immediately. That actually matches up, that pin pitch. Interesting. I don't know if I'd do this, though, because that puts this huge plug on the end. But it does mean that I could swap radios if I needed to. I put that there and then put another one of these guys there. It's still pretty big. Yeah, that makes my radio too big. I'll just simply do the crimps and then solder the crimps down to the pads, but at least I know that high-res is an option if I really need it. What would be badass is if I went and designed a one of those flexi cable PCBs. Or if I could, I wonder how you do that. You'd get Captain tape material, tape it down, tape down copper tape, cut it very carefully. I don't really think that works. And put Captain back on top of it. Little DIY rubber or DIY Captain substrate PCB. That'd be really cool to do. Although you can just buy like little short lengths of the Flexi PCB. Be a lot of trouble to go through, though. Oh, there's like significant dust in here. Eesh. But yeah, this is shocking how well this works. Having the arrow control when this thing is going balls to the wall. It's pretty funny, actually. Almost tempted to put a real car body on it, but I can't find anything silly enough. All right, let's put this away. Let's put this, well, at least just up here. And then I got to clean up a little bit. I was doing a little bit of wiring, and then I totally lost taste for it. And then I installed Fallout 4, and I started playing that again. I have about 100 hours in Fallout 4, and I'm finally installing mods and having some fun with that. I don't know what I'm going to do about the building mechanic, because that's going to take up all of my time, and I'll never get to the plot of the game. So I think what I'm going to do is not really emphasize the building stuff, because I know how addictive it is. Everything has to be perfect. Yeah, this is the last known communique from Oh Bother. It's true. That stuff is so dangerous. Danger. I haven't had a lot of time to get the little things done that I usually do in between streams because of all the uploading. This weekend I kind of pushed to finish all of my uploads very early and get me scheduled into the near future. But I you know, tomorrow I'm gonna have to really hit it home and do like 4 uploads maybe. Samples of blank flex PCB material, something like 18 by 24, 10 sheets. Never used it, probably could etch it. Yeah, you could probably you could probably just draw on that. What's up, Angry Pizza? Oh, I didn't pop out YouTube yet. If anybody's talking on YouTube, I'm sorry. I'm so sorry. I'll get you guys up there. Click on that, and then we got to pop this thing out, pop this sucker out. I don't think anybody talked on YouTube. Pop out chat. I'm not cool enough, not popular enough. Got a little bit of an internet presence. People are starting to talk on the VOD channel, so that's nice. Pyrolux. I've heard that name before. I think I've heard that name before. Pyrolux. It sounds like a casino, but I guess it's a material. I know it's a product name. That's why I said I think I've heard of that before. Now, what I'm looking for, my holy grail, right? The thing that I'm looking for, what I'm looking for is a Captain style copper tape. I want the same adhesives that are on Captain tape, but I want it on copper tape without busting my bank account. Because I've had people claim, oh, this is the stuff. This is what you need. It's this. It's just this. Here, this is what it is. Here, buy this, and I buy it, and it's just the same stuff. People just don't do proper research on things. I got a couple Funky Kong connectors, by the way. I think this is something like 80 Funky Kong connectors and 500 of the nuts. So I finally won't run out of these freaking things. Look at how many there are. It's full of stars. This is like my technical difficulties screen. There's so many. So the adhesive is made from polyamide, or you're talking about Pyrolux. Yeah, Pyrolux is just polyamide with copper on it, right? But what I'm looking for isn't polyamide with copper, and I'm not looking for conductive glues on the other side of the copper. I don't care about that. What I'm looking for is the adhesive from Captain Tape on copper. Because that's not what it has. The copper tapes have this conductive weakling sauce tape, which is fine if you're making a stained glass window or if you're doing like shielding, copper shielding on electronics. But what I'm looking for is something that I can lay down and make a trace out of. And then I can put UV epoxy on top of it and seal it. Or like if I need to make a surface mounted through-hole adapter, I can literally carve it out of the tape and then solder something down to it. Copper being more conductive than the polyamide. Yeah, maybe it stretches weird. Yeah, the bag breaks. I could pick these up with a magnet, he says. Tempting fate. Oh no! No. Welcome to twitch.tv/ohbother, where I don't do 5,000 projects a second. I would like to. I would love to be able to do that many projects. I see other creators, ones that show up in my chat, do 5,000 projects a minute, and I'm jealous of it. I'm sick with envy because he's getting all these cool things done. He made a depressed robot the other day. I have a Furby that we need to take apart. I guess it's kind of an anonymous Furby at the moment. We don't know. I don't know. The Furby was around here somewhere, but all I see is Fred over there, and he's new. But yeah, so at some point I would love to do something with robot kind of eyes and stuff like that. But it's right now I am tits deep into creating a modular synthesizer, and I want certain modules out of it, and we're working on certain facets of it in order to keep things interesting and flowing. I have done breadboarding, and so we found ourselves breadboarding a bunch of circuits. I got some ducks in a row over the break, and I figured out a little bit of a schematic that I want to try, and we're going to try putting capacitors in there in order to see if we could build all of the functionality of the Haji Wo input section out of a more mutables instruments style input. I don't know if anybody, these circuits, Mutable would probably be the first person to say, although I don't know anything about her, probably the first person to say, oh, this isn't my design. This is just something that everybody does. But I was introduced to these designs through Mutable Instruments, so I am liable to give credit to where I got my information from, which is what I try to do here. I try to do that here because things can get pretty complicated. Might be able to find a sheet of adhesive of that a sheet adhesive of that adhesive. Maybe. I was hoping that I could just get a convenient roll of copper looking tape and it would behave exactly like this stuff. That's it. That's all I want is this behavior out of copper tape, because I think that would be really good. And then you could get crazy with that. You could do really cool stuff with that. What I want to originally do with it, and I don't think I'm doing this anymore, but what I originally wanted to do with it was get a vinyl cutter, or finally build a CNC, and then I would be able to put down a repeating circuit element onto glass. So you would cut out with a vinyl cutter your layout, and then you would put masking tape over it, transfer it over to the glass, and that would be a repeating pattern on the glass that you could then solder components to, and then you wouldn't necessarily, I mean, you could seal it if you really wanted to, but then you could have a proximity activated LED thing that would be a circuit laid out on a coffee table, and you could still see through the coffee table. Yeah, it would be just a decorative glass circuit board. It would be sort of like a bridge between those sort of three-dimensional circuit boards that people put together. But I could never find the material. You can buy, you could buy the polyamide PCB, like, proto and then etch it, I guess, but it would still be orange. Yeah, and then sheets of adhesive copper exist, and you can cut those out with a vinyl cutter. It's kind of rough on the blade. Oh, that's where that went. I was looking for this. It's kind of rough on the blade, but you can do it. And then in the end, it doesn't really matter. No, in the end, I don't think it solders very well. I think when you apply heat to it, the pads just walk all over the place. So, yeah. Projects of yore. That would have been a cool one if I had finished it. Although it never would have been good enough. I would have been annoyed with how rough it looked. Yeah, I guess I got to abandon some of my aspirations to have the electronics be able to unplug and plug back into each other. Because, like, the servo plugging in is totally fine. That's all well and good. But, like, I'm missing the two sockets here on the other one. Unless I just swap the gyro out, but I don't. Then I've got this extra gyro that doesn't have anything plugged into it, and so the point of the plugs is so that it can swap out. Also, if the plugs are here, that means those plugs scrape on the ground when this thing crashes, which will break the wires. So doing it from under is probably the best bet. I'll say just put a body on the car, and then none of this will happen. 6502 CPUs, somebody made create thousands of LEDs about as large as a coffee table. That's pretty cool. I don't know. I may have seen it and I just I wasn't logging memory at the time or something. A lot of stuff passes by your intrepid streamer. And I try to look at it, but I also try not to be like other content creators because I'll too easily take on their memes. Have I missed any messages? I don't think so. Hiss. That'd be a crazy thing to do if you did like a big logic circuit and you had it all laid out on as like a coffee table. You could make it do basic math. 5 times 5, and everything starts blinking. There was the one guy that did the proximity sensing LEDs, and that's sort of what my idea was originally. Originally, it was a circuit from another creator. I think it was something that popped up on Hackaday, but it had, what do you call it? An infrared sensor and then an infrared emitter, and you would wave your hand over it, and then it would sort of make LEDs flash organically, and it would have sort of a drop off. So you could wave your hand over the table, and it would be like you'd leave behind sparkles. Do we finish the soldering job on the transistors? No. But I need to finish this up and test it. I'm gonna try to find time tomorrow to do the remainder of the soldering so that we can plug this thing in and see if it works. Because this is my own personal diode filter, and then the The other one that I have to get done is I need to do the programming for this guy, for the VCO. I need to tune this and do the programming for it so I can get the go-ahead to build another one and so that I can have something to give to Julian. Dave already has an oscilloscope. He bought that really, like, that $400 oscilloscope module, but I want to make the dinky little Hajiwo one. Maybe I'll make another one for Julian, and then I'll have the VCO and the O-scope to give to Julian. I was thinking about whether or not I wanted to use those round screens on these things, but we got to keep it cheap, I guess. We got to keep it cheap. It simply would be cool if it had a little round porthole kind of screen. But we've got a couple things to do with the O-scope yet, and I want to get the circuit kind of nailed to the ground. The circuit's job is to take the voltages in and turn it into something that's compatible with a 3.3 volt microcontroller. And I'm probably going to use the Pico Pi, even though I only need one analog input. The Pico Pi is like 1 billion digital outputs, but it should work pretty well. And this thing will be super duper fast, so I don't know if maybe we can get a better frequency response or not. No, it's not. And I bought one of those $30 US dollars oscilloscopes. I have all the parts. They're sitting in a bin to my, they're sitting over there. They're like right there. All the parts for that oscilloscope is there. It's got a really wide screen, which is not great for modular synthesizers because modular synthesizers don't have a ton of room for stuff. And so having something that I can stick onto that panel and give me my familiar oscilloscope look would be really nice. Another thing that I was thinking about is whether or not this could like tune input signals, although I don't know if it has good reference. I could use it to tune, like if I made like a C note waveform that would just overlay on it, and then I'd have to match it up to the waveform that's coming into it. I don't know if that's really something that I can do. I don't think it's gonna do measurement. I think that's the one thing that's gonna be missing because this is like a cheapo Arduino oscilloscope. It's not gonna be able to precisely measure stuff, but you can see what things are doing. And so that might be helpful. I guess just one of those free programs for your phone that helps you tune is what people typically use to tune their oscillators initially. But yeah, there's a couple things about the VCO that I still want to get into. One of them is that the frequency tuning is from 0 to whatever. It goes from 0 to whatever, and I want 0 to be in the middle so that you can go negative and positive on it instead of just from 0 to whatever. Because like if this thing is intrinsically tuned, that would mean that the frequency knob gets twisted all the way to the back, and then if it falls down in tuning, what do? You can't do anything. Or do you tune it in the, I mean, maybe it's me, maybe I'm the problem. Maybe instead I tune it with the knob in the middle, and then everything else comes out in the wash. But I just thought this thing would be intrinsically tuned in one location, but maybe that's the way to do it. These should probably have been closer together, but that power plug is tough. A lot of the way that companies are getting real estate on the circuit boards in the modular realm is instead of putting the circuit down like this, they'll put all their stuff down and then they'll put the circuit at a right angle because you got plenty of room going backwards on the module. I mean, you can do multiple layers of circuit boards with standoffs, but that tends to get expensive. So just put a flat circuit board out the back and you can have this huge circuit board with all your stuff on it inside your modular synthesizer. And then somebody buys it and they step on it, and then they show up on eBay and Julian buys it and gives it to me to fix. I know, they've discovered everything that all the electrical engineers came up with in like the 50s when they were doing card racks. Let's get our design open here. Let me move YouTube all the way over there. Where's my popped out YouTube? YouTrub, where'd you go? Oh, there it is. Hiding. Put that over there. Okay, we got all that stuff there. Let's see. Let's see. We've got mutable instruments schematics up. I need to open up. Oh, we have Hajiwo already open on this machine, so I need to go to MS Paint. MS Paint. We're going to open up our schematic. I don't think that's it. Yeah, it's untitled. I forgot to title it. But I've been doing a little bit of work with this stuff, trying to figure out what we're going to do. There should be one with a bunch of arrows. Here it is. We're gonna build this. I've done some of the circuit stuff for it. We still need to figure out switching of 2.5 volts. We'll get to that eventually, but first we'll set it all up. Just wait till they discover ASICs. We have plenty of ASICs. I have some sitting over there in this pile. Somewhere in this pile, there's some voltage-controlled amplifier ASICs. Yeah, I'd like to get to testing the diode filter possibly Thursday if I can get time to work on it. I have to do a bunch of uploads this weekend because I'm at 160 to go. 160 to go. That number's going to boil away hopefully soon because I'm fucking exhausted. I am exhausted. I don't know if at that point should I go through my VODs and figure out what's happening in the VODs on YouTube, the YouTube VODs, because there's a much smaller pile of YouTube VODs. It's probably like 20 videos or something, right? That means reliving the skull speaker that I completely fucking farted on. I failed that one so hard. That skull speaker beat me, and I don't understand why or how. I don't understand why or how. The circuits were so simple, and we were doing and building them so simply. We put it together, and it just didn't work. Just didn't work. Maybe my understanding of modular synthesizer power and voltages and stuff like that being a little bit expanded because we've really been hitting the analog stuff hard. Maybe then when I get back to the skull speaker, I can actually make it work. I want a stupid little cyber skull speaker that my synthesizer can communicate with. I mean cyber because we're just putting like resistors on the outside of it. 51 months. I'm auto-renewing? Oh no! Keeper of maps! I see you. I see you out there almost every day. Come on now. Thank you so much for supporting me. I'm serious. It really is nice to see people coming back. 51 months. Those numbers are getting big. Turn this on. We have a full minute until it does anything. This thing even work? The first boot up is like 4 minutes, but it gets better after that. I felt like it was broken at first. A lot can happen in a minute. Also, a lot cannot happen in a minute, which is what is not happening right now. Yep. Okay, well. Oh! Made a noise. And oscilloscope. It was just before I said it. You know, something I've never really messed with on streaming is sync delay. I don't know if you guys see like the snapping happening before the noise and stuff. A lot of the streams that I watch don't do face cam or anything like that. So if their audio timing coming from the microphone is off from everything, it doesn't affect anything because you can't see lips moving. I know that the human brain actually makes up for a lot of the delay in lip movement, and that there's actually like a known quantity of how far, I think it's behind the audio. No, I think it's in front of the audio, because you don't want, like, seems bearable currently. Well, that's what I go for. It's tolerable. I guess it's tolerable. Like if the snapping noise happens before I do the motion, people are bugged by it. It's like, whoa, that's off. But when you do the motion, your brain is like, well, maybe the snap came a little bit after they started moving, or maybe it was like mid-movement or towards the end of the movement. Maybe it took a little bit of time for the audio to get to me. Like for some reason, it's totally acceptable to have your audio lagging video. We don't need this up here at the moment. We're going to break down this circuit, this totally successful circuit that we built with timber. What's up, Lawlin? So we're gonna, well, fuck it. Let's just start. Let's just get started. I've already cursed too early into the video to get monetization. We have to be good. We have to be good. We cannot curse. Otherwise, Pepsi might get mad at us. It's so stupid. I hate this. I hate the advertiser-driven world. We should outlaw advertising for anything but peanuts. Those are the only advertisements we're allowed to have. Watch California Burbs and his collection of cameras. One day he spent time getting all the cameras in sync so things visible on camera were moving at the same time. Whoa, that's pretty good. Only 49 months from Miguel Oz. Hey, thank you for the 49 months, though. Holy shit. One day I'll be as cool as Keeper of Maps with his 51 months. Now, you guys can fight it out, and then to the victor goes the coolness. Thank you, Miguel Oz. Hey, that's a name I've known for quite some time on the stream. Sorry, I got a little burp. Yeah, what are we doing? Hi. I messed with the RC car a little bit over the break, over the weekend. I actually gave myself a little bit of time to relax and do something, and what I did was totally destroy this thing. But it turns out my efforts to build a wheel protection system really did actually work out, because this thing is quick. I've got a 7500 7500 kV. It's RPM per 1 volt. You get 1 volt to the motor. How many times does it spin within? I don't even know. There's some other weird kind of measurement there, but kV is the rating of the speed of the motor, I guess. Circuit analysis emote. I don't think I have that. But yeah, anyway, so the effect of the arrow on this RC car is kind of staggering. What I did is I took the rear spoiler, flipped it over, and put it on the front initially, and I drove the thing around, and it was poised. It was able to be controlled. I got it up to the higher throttle zone, which is usually the danger zone where this thing explodes. And what it did is it ejected all 4 wheels, all 4 tires out from each wheel. I was going along and I'm like, punch it. And I punch it. And then it just, all 4 of the rubber just went whoop, just like out from the model. And I was like, oh. And so I had to wander around the neighborhood like hunched over, and I managed to find all of the tires again. But apparently going max throttle just ejects the very low density rubber wheels, the 5 degree and 10 degree bricks. I think this one is 15 or 20. These wheels here that I have on now, those are really good. These are mini Z tires. So I guess I'm going to stick with those. When I had the good tires on, the good wheels on, and all of the aero was still intact, this thing goes really fast, and I was able to control it. And then it crashed, and the rear just left. It just left the mortal plane, and it's now somewhere in like Cthulhu land. Somebody's going to trip over it. But once that spoiler was gone, I tried racing it around, and it would slide really, really easily because there was less grip on the rear wheels. I never expected to have it to have such a stark effect on such a small model, but apparently it does. So I then redesigned the front and the rear, so the rear now has 2 curled upwards airfoils, I guess. I'm just trying to push air upwards. So I have 2 on each of them that are like staggered. Not really staggered, they're the same height, but they're one and then the other. So I'm hoping that they make a nice jet of air going straight up for my bodiless car. Putting a body on the car would probably save me from crashing and exploding, but I'm putting spoilers there in order to hit stuff. I'm not diffusing. I'm just pointing air upwards. That's all. And then in order to keep the electronics from eating themselves, which they've been doing, I am now crimping all the wires. All the wires will get a crimp before they get soldered together. And that way, when this thing jettisons the electronics time and time again, it won't break the wires. Because I had a couple times that I got out there and I went to turn on the RC car and it wouldn't turn on. And it's because a wire had bent too much and broke off. So making sure that all those wires have strain relief on their jacketing, not just soldered wire directly to the post. Once I get that done, I can see what this thing is like top speed, and maybe we'll have to take a stream or two at some point to make a phone mount for my controller so that I can film and not have to juggle 2 things at once or steer with my thumb because steering with my thumb, the thing will wander from one end to the other and I won't be able to get a video of it going full speed. So Yeah. How do you plan on strain relieving the wires? With crimps. It's just simply a matter of crimping an end on, and then I can solder up here. And although you're really not supposed to solder crimps, I don't have much choice. So if I solder the end here, solder will get into the crimped part, and it might stiffen up stuff back here. But really, what I'm going for is that right there, this right there, that little thing that's gripping the jacket of the wire will keep these from breaking when the electronics are going in and out of their holder. So, too bad we're not an RC car channel. Actually, if we were, then that's a whole host of pressures that I don't want to have. Like, oh, I have to make more RC car content. You know how sick you can get of a hobby that's expensive? Yeah, I think the best at this point, the best approach would be crimping and actually having the square housings that everything goes into. That way you can swap out electronics if stuff goes bad. I went with soldering because I didn't have space for everything, especially like the DOS Micro has those pads there. I actually just found out that I do have like a Hyros DF13 is the appropriate pin pitch to make it to all those pads. So I could have put a Hyros connector on the controller, on the radio, and put a 3-pin controller on the servo input to the radio. Or sorry, the channel 1 output comes from there. But then, yeah, there's a whole, I don't know, power distribution thing that I have to figure out. But anyway, I think what I'm going to do is I'm just going to solder below here with actual crimped connectors. And I have a little tiny bit of room under it. So and then shorten the wires so that I don't have a big mess of wires underneath this whole thing. And then I'll finally be done with the RC car. That's not true. That's just a lie. That is just a lie. I will never be done with it because it's a host of fun projects. But maybe I can move on to something like printing a body out or something. Because if I put a body on that RC car, then when it inevitably explodes against a curb, the plastic of the body will at least be able to take up some of the force. This is why the Nokia was such a famously indestructible phone. As soon as you drop it, it jettisons all its faceplates and takes up all that energy. Well, some of the energy. Yeah, we'll be done for now. Yeah, right. Done but not forgotten. At least I'll be able to take it outside and see how it performs. So where are we with all this stuff? I've been working on modular synthesizer stuff for some time. It's kind of taken over the stream, and rightly so. There are people who are interested in modular synthesizer projects and what goes into a modular synthesizer. And I'm trying to take this from a pretty basic level. We've done a lot of circuit board construction, then we got into some creating of perforated prototypes, and I've got 3 modular synthesizer things that are not done. And I would like to get them done as a push to give me some headspace to actually work on Burn the Subs. Burn the Subs is ever-present, ever-looming, always project that I am going to get working. There are a couple logical steps that we're taking, and there's some things that I got to learn on the back end here. I got to learn how to get Twitch working with Node-RED, which is something that I've been looking up. I've got pages open on the other computer. I just need to go through some really annoying procedures, and this is the kind of stuff that I just like to tears. Like it's like weathering a really, really cold breeze for me going through this stuff because it's so boring. It's so boring, and my brain just does not want it. It wants to do anything but. But I'll suffer through. I'll get this done, and we will have a Node-RED front end where we can censor things, and that will also enable the fart box to work again. Because for now, I am now back to 2016 oh bother without a fart box, without Burn the Subs, nothing going on, and a lot of too many projects. So where we are with modular synthesizers. So I have built a lot of stuff. There's a lot of stuff back there. Look at all that stuff. There's like multiple modules. There's one VCO. There's maybe a clouds filter down there. They might work. Some of them are even tuned, but they're all in kind of a weird space right now. I have played a little bit with the hardware itself, trying to make sounds, and all I could really manage was like a marching drum tune, because I have a basics module which does percussion. But there's 2 VCOs and filters sitting up there at by the other rack, and those are also broken. They just don't work. I didn't have enough experience with analog electronics to actually learn how any of this stuff works. So the natural reaction is to then pivot and push my face directly into analog electronics so that I can learn exactly how a bunch of stuff works. And at the same time, I can build up a little bit of capability from my modular rack so that I can actually start making pleasing noises instead of grating marching drums. So that took the form of building my own VCO, which isn't really my own. This is a design that is based on a YouTuber's design, Hajiwo, who creates affordable modular rack stuff. And I'm taking it just a little bit beyond affordable because I've incorporated some of the nicer electronics from the more expensive modular synthesizer modules. So because there is a huge DIY scene for modular synthesizers, what I'm doing, hey, what's up, Wonky Robot? What's sensor? It's a Logitech. There's a scope, exclamation point scope, so that my monologue isn't broken. So anyway, the modular synthesizer stuff, this VCO, I built based on Hajiwo. Hajiwo cobbled code together very quickly because Hajiwo is a prolific YouTuber and creates all kinds of wonderful content very quickly. It's very interesting to watch and see what stuff he puts together. But in doing so, it is sort of like grabbing Lego out of the bin and putting it together. And now you have a bunch of weird Lego that works for the task it's supposed to do, but it doesn't look nice and it's hard to understand. So what I did is I went through the code extensively and redid it. And we got a more understandable block of code that is able to produce nice wibbling noises by creating PWM tables, values of frequency tables and PWM tables, and it's able to output a pulse width modulated signal that then gets filtered into listenable audio. It's sort of like your waveform, your up and down waveform is being controlled similarly to a game of Flappy Bird, where when you give it a signal, it'll pop up a little bit, and you give it a signal, it'll pop up a little bit, and all the while it's falling. So it always tries to fall back down to zero, but you pop, 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 and you eventually make a wave out of that. That's sort of how at least one of the schemes of this thing is working. So yeah, so we have a VCO, but there's a couple things missing from it still. I pivoted immediately and I went to a different Hajiwo circuit because like I can have all the VCOs in the world, but if I don't have filters on them, they don't sound good. Although having like 20 VCOs would be really hilarious to do. Maybe when I get the budget to get a bunch more of these, I'll build up a bunch of these circuit boards. Yeah, it's Flappy Bird, but it's on a time scale that is unfathomable to humans. It's on a very small time scale. Anyway, so yeah, built this, observed it working, everything was great. We fixed our code, we got our code working, and now it is missing an LED routine that will blink the LED to tell you which numbered mode you're in out of 8. And then it's also missing tuning. It's not tuned. There's a couple errors on the circuit board. We fixed those in CAD, but I have a pile of these circuit boards. So I think I'm forced to just kind of live with my mistakes and make those corrections on the board. That's not that big of a deal. What do we even do to this to fix it? Not much. I mean, I flipped the connector around. That fixed the voltage thing. I did a one-wire bodge job in order to fix the op amp, which it was actually a little bit more involved than that. It wasn't just a one-wire bodge. It's actually kind of a complicated bodge. Oh, and then I cut one of the leads of the button in order to get that to work. So those are things that I don't know. Do I do that? Do I do that for 10 boards, or do I just buy 10 boards for like, what was it? It was like a $60 order for the 2 batches of boards. $60 to $70 order. Or board order. Blah, blah. And that was the day Bother died. Anyway, so yeah, the VCO is almost there. It's almost there. There's a couple little things I need to do, and they're boring. They're so boring, and so I just need to force myself to do those couple things. I don't know if I'm going to get to that Wednesday. I think Wednesday I need to finish the filter that we were building, because we had a couple streams of like wonderful soldering and me second-guessing myself on my design. We had to rebuild the same thing like 2 or 3 times, which is terrible for content. It's absolutely terrible for content. You guys can see that like there's nobody in any of my chats. I'm killing my own content here by not doing stuff that's engaging and funny. Anyway, so this thing is very nearly done. I just have to hook up all the power lines to it, basically. And then I think that's it. I think everything is there. I'll have to double check the circuit on everything too. And I'm going to do that on Wednesday. I'm going to do some uploading on Wednesday, and then I'll sit down with a pot of coffee and just finish this so that we can test this on Thursday and have something else to do. In the meantime, in against all of my own interests, I actually want to build an oscilloscope style circuit for this thing. And Hajiwo, of course, has exactly what we need for that. He basically took an SPI OLED screen, one of these things here. I'm trying to pull it out of the board, but now I'm just casually making it look like I'm just reflecting the light off of it. There we go. So these little guys, okay, we work differently, you and I, okay? We're not cut of the same cloth. I can drink an entire pot of coffee and have the steadiest hands in the world, as I do right now. No, I actually have extremely steady hands. I should have gone into surgery or massage. Yeah, I can drink all the coffee in the world and I'm still like tired and my hands don't shake. This thing right here, this is an OLED screen. I believe that this one can do blue and yellow, which means we'll have to modify code a little bit. This one will do blue and yellow, and they're nice looking screens. They look really good. And they're small. There's actually circular versions of this for like watches and stuff that I probably should have gotten. I think those are more expensive though. So anyway, this little SPI screen, we can get talking to an Arduino, namely a PicoPi Arduino, because I insist on I'm stuck in my old ways. I'm an old man stuck in my old ways. I insist on programming these things with Arduino code, even though these can take, you know, MicroPython, and they can use all these different languages that I don't use. So I want to put this guy, I want to turn this guy into an Arduino, put it on the board, and then I want to communicate with the screen. We need to give it the ability to see external signals so that I can have a module for the modular synthesizer that lets me look at what I'm familiar with, which is wibbling waves. And so we've got an extremely limited range of types of things that it would see. Low frequency oscillators, control voltages, audio signals. Those are in the positive to negative 5 volt realm. Anything above or below that should be either cut off or able to be tuned down in order to view it. So Hajiwo has, you know, pretty much exactly the circuit, and it's this thing here. This is his schematic diagram. So he's using an Arduino Nano, which is a 5 volt circuit. We're using a PicoPi, which is a 3.3 volt circuit. So there's a little bit of tuning here that needs to occur. Now, how do you do that tuning? Well, it's actually right here. This is all you would need. Although, to be fair, yeah, I guess with this gain, which is a 1 to 2 gain, if you got a full 5 volts in here, and then you use this gain, and this thing, I don't know what kind of power this thing has access to. If this thing has access to like a ton of power, it could blow up your Arduino. What is he using for his circuit here? MCP6232. Let's just quickly answer this question. Yeah, I think scope modules are really, really cool. We have a, I bought a $35 scope kit from Amazon because a viewer suggested it to me. Is that off by a little bit? Wait, why is that off by a little bit? Huh, I guess I'll leave it like that, but it just looks like I need to use the OBS zoom in function. I think Gonad tried to teach it to me the other day, and I've already forgotten about it. 20 microamp, 300 kilohertz, rail to rail. Documentation, datasheet. Supply 1.8 to 6 volts. So the op amp is able to operate rail to rail, but you only give it 5 volts. So it's actually not able to destroy. Wait a second. There's a person in that Tater's game MMO. What the hell? Who is that? What the heck? Ah, okay. I thought it was just a coffee emote. So it's fucking like Burt Reynolds coming out of the back of that thing. Okay, so we're limiting the voltage that goes into the microcontroller by not giving this op amp any more than the maximum voltage. So this only gets 5 volts. So it's only able to create a 5 volt signal. So if you have 5 volts coming in and this thing's going 1 to 2, if we're doubling because of the gain here, actually the gain here, because it's a non-inverting op amp. So there's the gain, and they're using a 10 kilo ohm resistor, and this one's a 10 kilo ohm, then you can have 10 and 10 I don't, for some reason my calculation said that it doubles. I don't know. I got double, but if we're doubling it, it's not able to produce 10 volts. It'll just make it cut off 5. Hey, that's a real Brule Story Co. That's a real cool one. Bye. Fucking assholes. Bots and bots and bots. We've hit bot threshold. How many viewers is that? I don't have my viewers open. I shouldn't complain about that. I complain about viewer numbers too much. It's 40 people. Yeah, 40, I guess, is like a sweet spot for them. They figure that the people who are going to be purchasing viewers... How scummy do you have to feel to do that, man? I would then say, I don't care about how many people are watching, but it's like all that I bitch about. So, okay, the point of the amplifier. Well, we got a couple things going on this circuit. Let's start from the beginning. So we have our voltage going in here, right? And so our power coming in is going to be plus minus 5 volts, right? Plus minus 5 volts. That is your typical 10 volt peak to peak modular synthesizer symbol. Modular synthesizer voltage. It's possible that you could see like 10 volts, positive 10 volts, if you're using a 0 volt per octave and you want a huge swing of octaves. But generally, that's frowned upon. So I think, all bets are off. Modular synthesizers are crazy and there are no rules. But typically, we would be seeing a plus minus 5 volt or something offset at 1 volt. You could do a line voltage, which is 1 volt, 0, 2. You could have a bunch of different things. I mean, you could have like an 8 volt pulse going in too. So the point is, you see all these varying different voltages that are coming in. Your microcontroller will fucking explode if it gets any more than 5 volts, right? Any more than 5 volts and that Arduino Nano will stop working immediately, and then you have a whole hot air soldering job in order to get it back working again. You got to get out the chip flasher, you got to do all that weird stuff with the console, you got to, blah 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 blah, remind yourself all the tricks, all the little shortfalls of putting together like a new microcontroller, and that generally is just not fun. So what you do is you limit the amount of voltage that can come out of this system. And so that's what this is doing. This is protecting this guy from like super duper crazy signals. And the way that it's doing that is by clamping the voltage with diodes. So what happens here is if I want to limit this to 3 volts, I give this one 3.3 and I give this one ground. And so the signal out can only go from ground to 3.3. Because if this is 3.3 plus, this Schottky diode, this very low activation voltage diode, will then allow for power to flow basically from, what is it? Well, if that's above 3.3, then 3.3 is going to want to flow current back through to that, I think. Did I get that wrong? Is it going to be ground? Well, 3.3 plus, below 3.3, and it goes through here. And probably down. I don't know. I always confuse myself when I talk about this, but the point is, when this thing is above 3.3, oh, it's above, yeah, that's right. It's above 3.3, so it activates this diode, and so 3.3 plus flows into 3.3. It flows this way into 3.3, and then it's pulled back down to 3.3. And if it goes below ground, if it's G minus, then it's going to want to get more potential from ground, which is above G minus. So then you get ground flowing in. It's just, it's all the directions are kind of confusing, but the point is having those two Schottky diodes there protect you against an external signal. My only problem is if you get a crazy super duper external signal, you can blow up your Schottky diodes and then all bets are off. But the second line of defense then goes into this MCP chip, and the MCP chip it's sensitive up to 5 volts. Well, it's 6 volts really. So if 7 volts comes through, this thing will see only 5 volts in this guy. And then in addition to that, if the gain is set too high, this thing can only output up to 5 volts. So there's a couple different pieces of protection right here going on. Not to mention that there's a voltage divider in effect here too, in order to knock your positive negative 5 volts down to a usable range. Yeah, plus minus 10 volts can exist in this system. But as long as we have our, well, the thing is that amplifier does not go below 1 to 1. It goes from 1 to 1 up to 1 to 2. I actually don't know how Schottky diodes, I don't know what the failure modus is for Schottky diodes. It's something worth looking up. They're BAT43s if you're curious. BAT43s are pretty universal. They're jelly bean parts for synthesizer stuff in terms of setting up protections. So from there, we actually have a low-pass filter. So we are filtering out anything above 9 kilohertz because anything above 9 kilohertz is just not relevant to what we need. The Arduino Nano can only go so fast, and so anything above 9 kilohertz, cut it off. The thing is, like, we're using a much faster microcontroller, so we might actually get away with higher than that. There's a means by which to turn this on and off, which is by switching a ground from a digital pin to the capacitors. So now suddenly you have this filter active instead of just two 1 kilo ohm resistors in your circuit path. Now, that's all well and good, right? All of those different things are going on here. And of course, you have a switch putting your audio through a 4.7 microfarad capacitor, which is going to remove the DC element. So if you have a waveform that's offset, if it's offset positively because you've got something that only has a positive power supply, not a negative power supply, not a virtual ground reference, it's the whole waveform is shifted up positive. It's like, that's how your headphones create, you know, a little low voltage battery operated device. It'll have like an offset of 2.5 volts. Actually, it won't. It'll be much less than that because headphones are much less voltage than that. Don't put 5 volts through your headphones. It's not a good idea. But anyway, it'll offset. It'll take the waveform like this and it'll offset it on a voltage so that it looks like this. And then that's what's fed to your headphones. And your headphones don't care. They're just an electromagnet. So they'll just reproduce the audio. So anyway, that's what this switch is for. This is to set it on the number line as a 0 or as an offset, and it'll help you. It'll help just in the event that you have a signal that's not quite lining up to be viewable on this thing. The pin junction goes suicide and the diode short circuits. That's not good. I mean, I guess if it short circuits, it's still going to be protecting you from that power because that power is going to come in and it's either going to go up or down, or it's going to feed back through the rest of the system. Maybe I don't like this. I don't know. Either way, I don't want to do this. I want to do a little bit more of a refined circuit, and that's what we're going to be testing here today. We're going to put together the circuit that I've come up with, and obviously I stole the circuit from Mutable Instruments. And so that's over here with this circuit here, and I've stuck a 50 kilo ohm resistor on the gain stage in order to enable this thing to go almost 1 to 2. I don't know if it's going to need to go fully 1 to 2. We have a 100 kilo ohm potentiometer in this breadboard, so we'll be able to see what happens. But basically, this is a little bit simpler, and it's utilizing an offset. So we have a negative 10 volt reference here. That's not the negative 10. This is this right here. Using an LM4040 B10, which again, that's a specific part number that I only know through Mutable Instruments. I'm sure there are other voltage references. I could use a Zener diode. I could put a Zener diode in there. I could expose it to negative 12. That's probably what this thing is. It's just a really nice Zener diode. I mean, the symbol is a freaking Zener diode. That's a Zener diode. So I could put like a Zener diode in there, but I happen to have these because I built a bunch of Mutable Instrument circuits. So I put together a bunch of Mutable Instrument circuits. I just happen to have a bin full of these things. You never order one. You don't order one unless it's like a $25 microcontroller. You never order one. You order 5, 10, 15, right? So then you have these parts available to you later on. So that's paid dividends for me. I've got parts coming out of my eyeballs. And so this LM4040 only needs 2 external parts and negative 12 volts. And we've got all that stuff on our board already, so I might as well include this. So we breadboarded this with the rest of the circuit, but what that negative 10 does is it mathematically, it uses the power of math in order to give you a half of that positive to negative 5 volts. If you think about it in terms of positive and negative 5 volts, this isn't exactly what it's doing, right? I'll explain exactly what it's doing in just a second here, but if you apply negative 10 to a positive negative 5 volts, you think of everything as a chart, right? Here, think of everything as a chart. I'll show you this. It's very neat because I think it's neat. And I hate math. I just have done a lot of math. Math is sort of that necessary evil of electronics. So if we get a nice big thing here and we have our number line like this. Oops, why did that? No, oh, God damn it. The line drawing tool in MS Paint is a little bit painful. We got that, and then we have our waveform, right? In this color. Oh, that's way too thin. We have our waveform. And our waveform at its max, that's too much. Positive 5 volt, negative 5 volt. At its min and max. But then we insert a negative 10 volt to that. It will then offset down here, on negative 5 volts. God, that's hard to draw. Okay, on negative 5 volts, they'll do this, and then it'll hit negative 5, negative 10. Not entirely the case, but I mean, I guess if you do the math, that'll come out like that. And so now we have this negative 0 to negative 10 volt signal, but that's going through an inverting op amp. So then it becomes a positive 0 to 10 volt signal. And if we take a third of it, negative a third, then that's 3.3 volts. Oh yeah, I am definitely sharing the wrong screen. I hate it when I do that. I don't know why I clicked that one and I thought it was totally okay. So yeah, what I was doing is drawing all this stuff and looking up at the screen like I was actually doing something meaningful. But yet you guys weren't here for any of it because I'm stupid. The mutable instruments input circuit? Yeah, I will in just a second here. I was getting to that. I was leading into it by just looking at the waveform. So if you apply a negative 10 volt signal to a positive negative 5 volt, you're offsetting it. So negative 5 plus negative 5 or whatever. Negative 5 times, no, I don't know how the math exactly works out, but either way, we're shifting it down into the negatives and then we're inverting it and scaling it by a third. And the way we're doing that is just with equations instead of visually like I tried to do here and didn't record because I was on another screen. Now, what happens inside of an op amp is driven by an equation. So if we look up basic op amp circuits, op amp circuits, I gotta get my other keyboard working. I got used to having a nice large keyboard on this thing. We keep coming back to this website. I'm not particularly married to it. It's just kind of big and clear and it's easy to see. The op amp circuits are all driven by voltages. And the way an op amp works is that it's got an incredibly large amount of gain on it. So there's something like a 1 to 700 gain inside of a TL072. If you just apply a voltage to one of these pins, it's going to come out as the negative difference of these two. Similar on the other end, right? And so if you feed that back into the original signal, it'll cancel it out. I guess that's right? Is that how they work? I think so. I'm going to second guess myself on all this because I thought I knew like 10 minutes ago, and then I'm looking at this voltage follower, and I'm like, wait, why does this one work? So you guys are just going to see me second guessing myself constantly today. But anyway, so yeah, we feed back into the op amp in order to lower the gain of the thing. That's why we have different resistor values there. And so the more resistance is on my feedback loop, the larger the signal is going to be on the other end. There's a lot more to it. I'm just trying to explain it kind of simply. So the typical configuration is an inverting op amp because we don't care if the signal inverts sort of within the operations of op amps, because if you do one thing with one op amp, you can just put a unity gain op amp on the other side and it'll just send that through and reverse it again. But anyway, so we have an inverting op amp and these are driven by an equation. So the output voltage is equal to the negative input voltage times the ratio of R2 over R1. So it's the feedback resistor over the input resistor. We are limiting the current, and they're doing all kinds of, yeah. So anyway, electronics is insidious and evil, and it's all math. And so we're utilizing this math, but we're also utilizing, well, there's the different structures, right? So this one would be a non-inverting, and the equation is slightly different. There's a 1 plus R1 over R2 because we're doing different stuff with our currents here. The summing amplifier, and this one is not really well explained here. The summing amplifier is basically the voltage outputs, and the voltage outputs are dictated by this equation right here. So negative VE R2 over R1, our R1 changes for whichever R we're doing here. So V2 and V1 are going to have different R1s that they go through. So you'd be using a lot of parentheses on this thing. Parenthesis, negative VE R2 over R1, and then you add that to the next voltage down the line, right? So that's kind of simple and easy. We have a summed voltage. So we have negative 10, and then we have it going through a 200K and a 33K. We can ignore the 50K for now. If we want to include the 50K, we add these two up together. I exited the pencil. We add these two up together, and so then this one is either 0 or 50. And so this whole branch right here, because nothing's branching off of it, would be from 83K. So 33 to 83K. 4, 5, 6, 7, 8. Yeah. 33 to 83K. Now I wanted it to be 33 to 66. Why did I put a 50K in there? Because 30Ks are harder to find, and I have 10K, 50K, and 100K. So finding a 33 kilo ohm potentiometer, while it can be done, it might be a little bit difficult. But anyway, the point is, this is going into an MCP 6002. So the MCP 6002 is only getting 5 volts. So if we were to have an incredibly large amount of gain, and I might want to go below, I might want that to be smaller. But we'll find that out when we actually build the circuit. We'll figure out what we want out of this thing. Because if I've got like a really huge, like crazy signal, I want to be able to tamp it down instead of just doubling it, which is all that this thing allows to have happen. But anyway, we have a plus minus 5 volt going in to this line here, and we have that biased 1 to 3. So that plus minus 5 volts is biased. Everything is, well, biased 1 to 3. That's going to drop it down from 10 volt, a potential 10 volt peak to peak, to a 3 volt peak to peak. Our negative 10 volts is in there to mix with that. That mixes with that and bumps it into a level where when it's inverted, that means it'll be 0 to 3.3 volts. And so in the math, we have 33, because remember this one is the numerator, 33 over 200 with a fixed negative 10 volts. And that coefficient comes out to 1.65, which if you're playing along at home, that is the half point of 3.3 volts. So we have a 1.65 volt, what is it? Not an operand, just this coefficient is always going to be 1.65 volts. That gets applied to the 1/3, the 1 to 3 break of the plus minus 5 volts, which becomes plus minus 1.65. It's like magic. So that means our range is from 0, as in 1.65 minus 1.65, to a full 3.3 volts, 1.65 plus 1.65. And that is the magic of op-amp math. Now, because this thing only gets 5 volts, or sorry, this thing only gets 3.3 volts, this MCP 6002 only gets 3 volts, it can't go above that 3 volts. So we've done the job of all of this stuff over here. We've done the job of this, and this, and this, all within one op-amp circuit. So while the passives are probably pretty cheap, to be honest, it lowers the complexity of the circuit quite a bit. As for the 2.5 volt offset reference, I don't know what to do about that, aside from something clever with MOSFETs and a 2.5 volt reference. So the thought is that maybe we do ground or 2.5 volts right here. What? Did you buy for your company full price? From is Bridgeport still around? I would guess they are. Oh, that's awesome. That's going to be fun as hell.
Don't be like me. Pull the whole thing apart. Pull the whole thing apart. Clean it up before you go full ham into machining, because it's going to be a lot of fun. Although maybe you do want to keep it in just the sense where you need to machine stuff for your machine. That's going to be fun on a bun. So 50K, I was thinking, like, could I put like 100K? Then I would do 100. But with that thing added in, so I don't know. This will all come out in the wash when we actually build the circuit. Yeah, how many health points? So yeah, we're doing the business that the other one's doing. Now, in addition to that, there is a 9 kilohertz low pass filter. The way you do that with an op amp is to prevent ringing. You can actually prevent ringing at high frequencies with an op amp by putting, I'll go back to black here, by putting a capacitor in series with the feedback. And so what happens is, at high frequencies, when those waves start wibbling really high, this thing will start letting stuff through, and then that will provide you with more damping to your signal. So what value is that? I don't know. Now, on the mutable circuits, Amelia uses, I don't know actually what they use. Hold on a second. 1 nanofarad. But I don't know how that gets to 9 kilohertz. Yeah, 18 pico is another value that's used. We'll have to do some frequency sweeps. So 18 puff for 9 nuff. Lots of question marks. Okay, so all those, and again, this is the point that I got with the circuit analysis. I decided to actually break it down into math and figure out what the math is doing and how to double the current. And this is the stuff that I typically try to avoid right here. This stuff right here. It is very simple math. We're still in the sort of clever realm of electrical engineering instead of the hardcore math realm of electrical engineering that I used to live in. That's why my manufacturing machine is an FDM 3D printer. Yeah, 3D printers are quite nice these days. Considering all the resources have sort of caught up to them, and there are enough guides where you can tune your printer like perfectly, it would be cool if they took an approach from like normal printers and you had some kind of a tuning thing that could run automatically. What's up? Oh God, this is going to take me a little while. Hoyan Adenoma. Hoyan Adenoma. Welcome, welcome, welcome. We're doing a little bit of math so that we can do a little bit of stuff with our hands. I don't want to do just equations today, right? Followed from Flatulent Gonad. Hope you have a neat stream. Well, you're not welcome here. I don't know why you would follow me from Gonad. We have explicit import and export regulations going on this sort of thing. You know, you're coming here from, where is it, northern England? I don't know if you could have a pathogen. Like, I can't let you in. I said it perfectly. Cool. Hayana. So anyway, we're doing the math of audio circuits right now. I got into this big thing. Oh, you're in Boston, so I can be a total asshole to you, and it's fine. It's fine. I can treat you as subhuman, and it's totally fine because you're from Boston, and people are mean in Boston. What was the Reddit comment that I read recently? Was that I've never seen like a person hit a car before, but I did in Boston. Usually you see them get hit by a car. I should probably get the insulin syringes out of the way here. I just ordered a bunch of shirts and insulin syringes. I should be wearing one of the new shirts. Okay, sorry about the pop. There we go. So, modular synthesizer. We've been doing this for quite some time now, and I've been trying to get this thing up and running and functioning, and it's been an utter pain in the ass, but I've been learning about analog circuits. And so I've been trying to avoid the brutal math that engineering brings to the table. This is sort of the clever math, where you go, ooh, if I put a negative 10 volts signal into this op amp, then it'll shift everything for me. I'm a clever boy. and it's all just basic like grade school math like this stuff, right? And if you can stay in that realm, that's really great. If you start getting into circuit loops and like control systems math, things get real hinky real fast, and it's nice to kind of be in this realm and sort of the high school math area of just adding and subtracting things in op amps. Now, what I found to be really fun is what we did last week on Friday, which is where we actually just breadboarded the circuit and just see what comes out in the wash. And so we're going to do that again. Oh, see, it's fucking just a little bit of math, and Lullen just scarpers off like that. Wait, did that comment actually show up on? Hold on, that's. Oh yeah, there it is. Okay, just a little bit of math, and Lullen just fucking ups and leaves. Okay, well anyway, so the point is, this math is all well and good, and it's good to prove out your theories, but at a certain point, you have to be ready to fail. You have to fail. You have to fail in order to get better at this stuff. And so, you know, I did a little bit of the math, and I've got a little bit of an idea of what the circuit's going to do, but it's time to actually put things down on the table and actually build this thing. I know, me when math. I saw math and I turned on a heel. It's time to just build this thing and just see what happens, right? And if we blow stuff up, God damn it, we'll finally have blown something. See, look, I refuse, on this channel, I refuse to pull I forgot the YouTuber name. The guy with the unibrow that blows everything up. I don't want to do that because I watch him and I can see he's clearly acting, and everybody else knows he's acting. A few people don't. Electro Boom. I should have just put like the two things that are. It's my brain. This is how I feel about mechanical design. Just build it. Yeah, at a certain point, I think both of it, because electrical and mechanical engineering are the same side of an Ouroboros. Wait, what am I saying? They're two different sides of a coin, but they're the same fucking coin, right? Eventually, it's like I could do this and I could do that, and this works this way and this works that way. It's like just go do it. Go do it. Go do a test. See what happens, because it's more fun that way too. And after all, I'm on an entertainment platform. I need to be more entertaining. So let's, instead of just running the numbers, I've explained them. We're done with that. We're gonna put this thing together and just see what happens. Yeah, learn how to weld. Learn how to weld. Dig a hole in the ground. Like get out there. Go touch grass. Kill the grass. This is why I bought 10 of the same chips so I could blow up 8 before I get into my final 2 designs. That is the primary reason why quantities never go below 2. Right? Like, this is why I have a bin full of stuff. And I've even got stuff in here that's labeled as dead. Some of these have like an X through the chip on the top. And what that teaches you is how to recover from a dead chip. That's why I got good at soldering, because I kept breaking all my stuff. First scope showing up today. What probes and accessories do you recommend? Just this, that's all. If you're doing modular synthesizer stuff like I am, I've found that BNC to mono cables are amazing. BNC is your friend. This is a beautiful connection, although this one kind of sucks because it keeps disconnecting. BNCs, you push it in and you twist 90 degrees. Actually, yeah, 90 degrees. And it has this 50 ohm coaxial connection that's very low loss. But the thing is, you put it together and it's a definitive connection, and nothing moves, nothing changes, everything is connected perfectly. So BNC hardware is one thing, although I haven't needed it for 10,000 years. The probes, I use the probes that came with the scope because I buy good scopes. My thing is, and it's the same thing with like any creator, right? Anybody who you see who's gotten to the level where they're broadcasting this stuff is so talented with it and does it so often that they are buying really nice hardware. And so I don't mess around with bad hardware. You will, because you're just starting out, I presume, because you just got your first scope. So just starting out, I mean, you can get away with using a lot of different stuff. There's some cheap stuff out there. Yeah, even the cheap scopes have the okay probes. Yeah, exactly. And I I have the privilege of having really nice probes because I use this scope more than once a week, more than twice a week. Adam Savage's, I think his philosophy was you buy the cheap tool, and if it breaks, then you know that you need the good tool, right? And so I kind of live by that philosophy to a degree. Although I never buy the cheapest of stuff, but then again, I always temper that against how often am I going to use this thing? So it's a whole song and dance, and any recommendation coming from me is not going to be applicable to you. That's the big thing that I caution against when people ask me about, what gear do I get? How do I do this? How do I do that? I'm like, well, if you were me, you would do this, but you're not. So you really need to like look at how much am I willing to spend? How often am I using this thing? If it's, you can get real, here, I've got some cheap probes over here. Where are these things? They bought us these as replacements at my old bomb job, and I kept them. I stole from the federal government. It was like 10 years ago, though. I think I'm out of the statutes of limitations. These are cheapy little probes, right? But they're really good because they're really sharp, and they have replacement tips. I have taken the jacket out from around the BNC, but like I wouldn't be able to use them here. I'd use them on a multimeter, but these are just multimeter probes, and they've just got a very sharp tip on them. The scope probes actually typically will have like a ground connection floating off of it that you can use, hook up to a local ground, and then you can look at signals that way. But these are cheap, and they're still really, really good is what I'm trying to say. I'm going to put them back before I get arrested. Oh, I've messed up all of my cable hanging over here. I need to set up an area of the shop that has all these wires hanging from cable hangers, because it's better for the wires and it's easier for me to find stuff. My cable's stuck. Oh, did you guys see this thing that I got out for Uwu to Oo? I got my... Have you guys ever seen my actuator at full extension? You have now. This is just some of the stuff that, like, Uwu to Oo. Would love to collaborate with them, but I can't figure out how. I don't know what I do. And this is a 300 volt, three-phase motored linear actuator that was given to me because it fell off, the machine fell off of the truck during loading. And so there's cosmetic scratches on the outside of this thing. It's amazing having engineering friends. But I don't know what I'm going to do with this. I need 5 more in order to build a full robotic motion rig. You imagine 2 of those on each corner of a platform? Oh my God, that would be amazing. Oh, what was my quote? Was it about getting arrested? Okay, solderless breadboard. I'm probably preaching to the choir on this one, but solderless breadboard is mighty, mighty useful in an electronics situation because you are able to make these connections that are only made with little clips. The inside of these rows and these columns are basically what are like fingerboards of little clips that are bent together. And when you put a component in there, that component then clamps onto, gets clamped on by the little clips. And so we can connect vertical rows of these 5 holes or power lines across the horizontal ones. And so last week we built this circuit here, which is a variation. What is it again? This thing is a timber circuit, and I just wanted to build it because I don't know what timber is. I just wanted to see what it was. My advice with solderless breadboards: be ready to throw them away when they are consumable. I still have all of my solderless breadboards. One thing that I did have to do on some of the solderless breadboards was actually break it in and take a pin tool and just hammer it into all of the holes so that the clips separated a little bit, because if these things go bad, they can kind of hurt your electronics. Now, we've got all of the players here in front of us. We've got a bunch of resistors, we've got a bunch of connections already made. I have to pretty much rip up all of this in order to build the circuit for today. And then we'll get that together and we'll get it testing, and we'll see whether or not I have a go-ahead to start building the oscilloscope. Yes, sir, yes, sir. It's another one of these streams where I just kind of build something. But we were so successful last time. I mean, this went together really well, and we were able to produce this circuit and get it tested and look at it on the scope, and everything looked really good. Just pull these up, and then let's disconnect the power connections for right now. Just get all these components up and out. Now this is the LM117. I'm going to need that for power. I'll just put that over here. The TLO72 I'm not going to need. That's what this chip is here. TLO72 is a plus minus 12 volt chip. So it's good for making the outputs from your systems. It's also good at receiving inputs, but it's also pretty good at blowing up your microcontrollers, so your 3-volt microcontroller. So it's not a good candidate for our our microcontroller facing op amp. When we're giving an analog input signal to a micro, we do not want that coming from a TL07 series. We want that coming from the MCP, because the MCP 6002 and 4 are only low voltage. I think they might be able to go up to 5, but we can give them 3 and they work perfectly. And then maybe I'll get away with using, what do you call it? One of my through-hole capacitor kits as the caps here. We might have to solder a couple of these little female pin header to surface mount component things, because I mainly work in surface mount when I'm building stuff. I very seldom use like through-hole for the hardcore circuits that I do. So as a surface mount faced person, I don't have through-hole 18P capacitors. I guess I could probably find them, but usually when we go scrounging, we don't find what we need. And this is much faster. What I do is I take a female pin header that is too small for typical square headers. Typical square headers are these guys. And there are rounded pin headers, and then there are rounded pin headers that are similarly sized to these that work really well. And then there are ones that are much smaller, which is what this was. I tried to buy female header that would work with square pins. It exists, it's out there, but it's hard to find. All the listings are for this stuff. So I have tons of this stuff, and I need to use it up a little bit. But anyway, this is a good thing because it gives you two nice flat pads, and you just load one up with solder, get your part on there, and then load the other one up with solder, and then you have a surface mount component on a solderless breadboard, and it's just got a number on it. You can just look, there's a number. That number is the value of the resistor. It's amazing. It's amazing. The technology that we have available to us. Okay, so we have an MCP 6002, where the number at the end is just the number of op amps that are inside of it. We have a couple little helper boards here. This one has a 10 kilo ohm potentiometer and a 100 kilo ohm potentiometer. So we can shove all this stuff together, and we can actually see whether or not this will create a viable circuit. We have our input and output, nothing connected to it right now. So we need to get a 100 kilo ohm and a 200 kilo ohm circuit. Now, because we just built this thing with different stuff, I have a feeling the 100 and 200 are already out, but I don't want to look up the old Roy G. Biv resistor value chart. We were supposed to memorize that in college, and I was like, this is useless. We have surface mount. I'm never going to do this. So I never did. And it pays dividends not having memorized it, because I saved all that time. And now every single time I look up a resistor, I need to go get a multimeter. Sucks. Electronics is also all statistics. So the values that you see from the multimeter are not going to be exactly 100 and 200 kilo ohms. You ballpark it. Everything is kind of a ballpark in this. You can get 1% deviation resistors, but typically don't. On an actual product, you wouldn't do that, because they're a little bit more expensive. And why do that when you can buy a yacht and buy 5% variation resistors? There's our 100 kilo ohms. So this is our input from the outside world. How do I want to do that? Actually, I think I'm going to make this one the input, because it's a little closer to everybody. And so 100 kilo ohms is coming directly from our positive negative 5 volts. And then that comes from, the other place I could put, no, this is pretty much should come from here. So it's coming from this bottom pin here. Means I should probably get this one out of the way, because that's gonna unplug our pin, and that's gonna be really annoying. Where'd my kit go? Here they are. These are the disposable things, these kits of wires, because they'll get gradually more disorganized as you work with the circuit, and work with more and more circuits, and you could just toss those in the garbage. You just throw them at marine life. Eat this, flipper. Yeah. and then it makes dolphin noises, sad dolphin noises. This one's too long, right? Yeah, that one's getting me all the way down there. Actually, I could kind of fudge it and just bend these pins in a little bit more, and that'll fit like that. I'm putting it at the bottom row because I have just a little bit of room above it. And then this one, the output will be taken over with a longer wire. See, this one is, they're all in reference to ground, all the external signals. There's that ground and ground. And then over here, we need tweezers for this. That's kind of cool. Oh, that's right. Yeah, because if you got like a set of colored tapes, which are important in production, you can use those to number things. That's clever. That's actually pretty clever. Counterpoint. Where did that thing go? Hold on a sec. I have a counterpoint. Yep, there it is. Just right in front of me. Counterpoint. Numbered tape. The tape has numbers. It's got a cool little dispenser. Oh, these get kind of greasy eventually, but I mean, you know. I use that to number cables. There's also shrink wrap printed labels. The adhesive isn't as good on those though. They get pretty greasy. You head to the breadboard. Hey, Brink GG, entering the breadboard. Brink, thank you so much for the 12 months. Okay, so we're starting out. We've got our first 100 kilo ohm resistor in. That would be, let's see, where is MS Paint? There we go. So first 100K going in right there, and then that's got to go to the input to the MCP 6004, which is what pin. I've got to open up the MCP 6004 data sheet and take a look at what pin does what, where, why, who, how, and blah, blah. So let's see, MCP, I've still got it open. This one is the wrong one. That's the wrong one. Got that one open. We were just looking that up to see what Hajuo was up to. Here is, that's a TLS72, MCP 6000, blah, blah, blah. Okay, there it is. So MCP 6001, 1U, 2, and 4. So MCP 6002 right here. VDD and well, see, the DD and the DS and the SS and the LM, whatever the hell, all those voltage labels are always so confusing. I don't know why they call it VDD. They could come up with a little bit of a better thing for that. But anyway, VDD is our positive. So that is on pin 8. And so we've got this thing facing that way. So this one is pin 8 right here. That's our positive power. And then we're going to want this thing to go into the minus input, which is on pin 6, one from the back. So like this. And now we've got that 100 kilo ohm going into there. I guess our next piece of this is going to be to do a negative 10 volts into the same place, but through a 200K resistor. So I could either put that here. I probably should put it down here just so it kind of communicates that it's going negative there. My guess is pin 2. Were you right? Whoa, that's the wrong scene. Pin 2. Well, it is pin 2, but it's also pin 6 because we're on that side right now. So we need positive and negative connections, and since this is a analog circuit that we're working on, we're going to have a positive 12 volt rail, 2 ground rails, and then a negative 12 volt rail. So I need to connect this thing up to the positive rail over on VDD, which is over here. Here, let me go to the microscope view. You guys will see things a little bit better that way. We don't need the scope in here right now. I need to put those on Stream Deck buttons. my God, I'm clicking. I'm using the mouse with my left hand. Actually, no, it was the right hand. Whatever. Okay, so now we have that connection there. Now we need to do positive power and negative power. Let me bend this a little bit. I don't like reusing parts in the solderless breadboard. That's like the primary purpose of it is that you can reuse the parts. I don't like doing that, but I do sometimes. And you gotta like bend out all the little bends that are in there. It's like a cooking show here where we never actually use any of the ingredients. They'll get thrown out at the end of the day. And then this one goes down to, damn it. I hate these little breaks that they put. I hate these little breaks. Oh wait, no, this one goes to ground. The MCP 6004 does not go to -12. It goes to ground. So we'll just do that. It'll be a little sloppy, but whatever. That would have blown up my op amp. And possibly had a viral clip. Damn it. I keep working against myself. What is the negative doing in here? Oh, the negative is going to ground, and then later we will alter where the negative is going. So, sorry, positive. Positive goes to ground. So positive to ground. Positive is this one right here, and that's going to ground, which is this one. But later, we'll have that cut off, and we'll put that to 2.5 volts, in which case I will need to get a 2.5 volt reference, because we've only got 3 volts on this board. So there's our first bout. Now we need to figure out where our 200 kilo ohm resistor got off to. Where do you get off? Here, I won't build stuff in this view. I'll build stuff in the microscope view, so this one can be unperturbed. Seeing as this circuit was what we pretty much already built, I wonder who came up with this circuit originally with the -10 volt reference. I bet you it's in an application note somewhere. 10K. 100K. Wait, which one's this one? Oh, another 100K. Okay, so 100, 100. One of y'all is 200. Another. Oh, you know what? I built a 200 kilo ohm resistor. That's what I did. I put two 100s together. So maybe we'll just do that again. Yeah, that one's 39. So yeah, these two will go together. Oh, we got a hole that's not cooperating. Sometimes the clip doesn't quite cooperate. Apologies from in and out at work today. How dare you? You know what? Why am I even here? You know, that's rude. Nah, man, have a good work day. I don't mind you guys being in and out. This is like a revolving door of people. Like, we don't see certain people until later in the afternoon anyway. So everybody's half paying attention. It's not like I have a lesson plan. No clue 321. Hey, thank you for subbing. Yeah, there's no lesson plan, so you're free. You're free. I can't control you at all. If I could, I'd have more viewers. I'm gonna put this in here. I probably should extend it out a little bit because this thing is like where I bent it. These are kind of, well, actually, this is, yeah, that's not good. But I need to avoid metal on metal contact here. I mean, I gotta rebend this one then. That's the way of it, though. I mean, I'm sure that's what everybody else is doing too. That's why I get when I explain, I painstakingly explain exactly why I'm doing something one way instead of another, and then somebody comes in and goes, "Why aren't you doing it the other way?" It's like, I just said it. But that's just because people are half paying attention. My content is not as punchy as a gameplay thing. I hope we have enough shocking things happening on screen. I know a diabetic friend of mine once watched my show, and he was like, I gasped when you did the polar paper thing, you know, where you remove the polar paper from something like a monitor, and then you can show the monitor by holding up the polar paper. We've done a lot of stuff like that where I've done the stuff like the hot air soldering or the soldering on a plate, and later on, like even that day, later on that week, I will pull up something on Reddit and it'll be exactly what we did, only it got an incredible amount of engagement. Thousands and thousands of viewers, and I'm like, I did that. So -10 is on the center pin of this. The right-hand side goes to -12 and the left-hand side goes to ground. So we can just do that real quick. And the reason that I know that is that we built this entire circuit right here on its own little board. This whole thing is on its own little board. And so I just have the input and the output for this thing ready to go. Although this thing gets kind of hot, or rather this gets kind of hot. And I don't know if maybe I need to do something else with it a little bit. Maybe that resistor is a little bit too small. Maybe it's too big. Microspring, there we go. So yeah, this is all, we built this board and then we labeled it. So ground, -10, -12. We may need to build a 2.5 volt version of this thing though. So ground -10, -2.5 is going to be a tough thing to actually put on the label, isn't it? Huh. Anyway. God, the Mutable Instruments designs are so good. They have so many like op amps and stuff in them, and they're all using that -10. Just hoping to capture a little bit of that magic. I should probably find out where the Mutables design comes from, though, so I can give better credit where it's due, because Amelia is where I got it, but where did Amelia get it from? Or is it like a super common thing? So this one goes to -12, so that goes all the way down here, which means a green wire. A green wire! Sorry, I try to keep my own self entertained when I do these streams, so I like doing weird voices when I'm working. So -12, -10, ground. -10 is going through not only one, but two 100 kilo ohm resistors in order to make that 200 kilo ohm resistor. And so now we have our voltage reference going into the negative pin of the op amp, which it's power plus minus out. Hold on, gotta check. This is why we do this. I constantly review even the simplest circuits because things go wrong. Sometimes they go really wrong. We have VDD output minus plus. So there's your mistake. And oh, not again. This is biting me in so many ways. Like these perforated prototyping board, I am going to assume, sorry, not perforated, solderless breadboard, I am going to assume was invented in the first place to deal with op-amp circuits because they require so much tuning and playing with in order to get things the way you want them to. And as such, I believe that row of 5 holes is probably based loosely on the number of holes on your typical op-amp package, the number of pins. I don't know. I'm probably wrong about that, but it seems very convenient the way this thing works, that these op-amp circuits go down so easy. Okay, so now we have positive and negative power. We don't have a decoupling capacitor because this is just a test circuit. We have two 100 ohm, boop, boop, going to a -10 volt source. We have our input coming directly in with no capaciting, like capacitor style static electricity filtering. We just have that coming straight in, raw dogging it, through a 100 kilo ohm resistor into that same junction. Then we have feedback. And so feedback is a little bit inconvenient here, but what we're going to do is I am going to hook up the feedback as the potentiometer all the way over here. Although, you know, probably should just move these over. It'd be much more convenient. We've only got one chip going into this thing. So that goes directly to it. And I think what I want to do is just hop, skip, and jump directly over. In order to do that, I need... These are inert, the connectors up here. So this one's our 100K, right? Yeah. So 10K, 100K. And we're going to do one of those two things and then one thing there. I think I'll just go up over top and just slink my way over. What's this one again? Oh. Dun, dun, dun. There we go. So yeah, let's just get a slightly longer wire. It's too long. Oh, are we in that? We're in that size. That particular length of signal wire that these kits don't cover. The kits are, the kits are pretty good. They've got a lot of good stuff in them. But when you get to a certain length of connection, they just simply don't have anything. So just bend it like that. Put another one down here. Those will just be two lines that are like on top of each other. Actually, you know what? If I just take that and move it to the other side, that'll be much cleaner. Much cleaner. Let's just move this over. Shove it all the way down here, and then we can just go up and over with a longer wire. Of course, that might still be the wrong distance. Hold on. So, well, actually, two of these are going to jump into one another. So get one of these. That just turns it into like a two-pole wiper. What kind of wiper are you, chat? Don't answer that question. I don't want to know. I really don't want to know. Okay, so that just makes it into a two-pole wiper, basically, in the configuration that it's in right there. This can go now from 0 ohms all the way up to 100 ohms. We'll just see what that says for the range of the input signals. And maybe we don't need a 33K and a 50K. Our MCP 6002 is what's going to be limiting the amount of current that the whole thing gets. And actually, wait, I hooked it up. That would have blown up our chip. So that needs to get positive 3.3 volts from the regulator. So what should I do first? Let's just hook up the rest of this, and then we'll put our other power supply into play. So yeah, let's get this one here from our output. We got to get the one next to it too. And that's just going to go right here. Too long of a wire. I don't have any choice though. It's coming from here. And then the next one, same wire length. Just get it from here. Wait, which one are we going to? We're going to this one. Okay, so like that. So there's our potentiometer hooked up as the feedback resistor. And now we need to get 3 volts into this side, because this one goes to ground, this one goes to 3 volts, and our input signals go plus and minus 5, which will be controlled by the frequency generator. And then, what else? Yeah, 3.3 volts. No negatives in there. What are you talking about? So we'll make that voltage right next to where we made the other one. So we made negative 10 there. We'll make 3 volts over here. These are labeled on the other side. So V in, out, and ground. V in, V out, ground. Well, V in is going to be positive 12 volts, which is all the way over here. So maybe I'll do this. That's a little bit, that's flirting with disaster is what that is. Zap, zap, zap. No, thank you. Silly question, how are you planning on getting the different voltage levels? So voltages are just potential differences, and I always worry that I'm being condescending with chat, but I'm going to explain this on some very rudimentary terms. How do we get positive and negative voltages? It's kind of a little bit mind-blowing, right? Well, you kind of take a step back from the whole system and you go, wait, voltages are potentials. It's just a sort of difference in the tendency to flow electrons from one potential to the other, right? So in order to create negative 12 volts, we could just take a second 12-volt power supply and counterintuitively, hook the positive 12 volts to ground. And so you have 3 different poles now. You have the first power supply is ground. You have a ground and plus 12 volts, and then you have a plus 12 volts. And what that does is that ground point that you're calling ground is now a potential difference. So from negative 12 to positive 12, you have 24 volts. From negative 12, which is labeled ground on the one power supply, to ground and the other power supply, ground and the other power supply is plus 12, that has a potential of 12 volts in the opposite direction, and then the positive is on the other way. So specifically, though, the way that I'm making 3 volts is by using an LM117, and I'm hooking it up between positive 12 volts and ground, because this thing can take in 12 volts and create 3.3. The LM1117 3-volt flavor and 5-volt flavor is a very much loved voltage regulator. It's like the 7805 of the modular synthesizer world. It's got a decent amount of power. It's small. It doesn't produce a ton of heat. It's very common. It's cheap to find. It's easy to find, and it produces decent enough power at, it's like 1 amp. That's clean. So you get about an amp out of these things. Amp is probably pushing it, but since all we're doing is wibbling voltages around, we don't need work amount of currents. Yeah, and then to be lazy, I bought a negative 10 volt reference chip. So we got 3.3 volts, we got a negative 10 volt reference chip. Positive and negative 12 volts is actually coming from my Agilent power supply. And the reason for that is that this is a big boy power supply. This creates incredibly clean current that is tunable and all that stuff. And it tells me how many amps are being used. So the Agilent power supply is the workhorse of this whole thing, creating plus and minus 12. In the modular synthesizer, I actually bought a module. You take plus minus 15 volts in. I bought a module that specifically makes negative 12 volts, and then I bought Pololu voltage regulator modules to make positive 12 and 5. We're not even using 5. I'm not using 5 anywhere in the synthesizer. I'm just making my 5 with a regulator if I need it. Yeah, and ground is relative to whatever potentials you have. Yep. What was the negative 10 volt chip? It is an LM4040. Here. LM4040B10. This thing cannot create a lot of current. It's basically just a Zener diode. And a Zener diode is a diode it's been baked in a particular way to give you a very sharp drop off so that any excess voltage going to the one side of the diode gets bled through and off, and the diode has a specific voltage that it sits at. I don't know if this is a Zener diode or not. In the silicon, it might be, but it's the reference chip that Mutable Instruments uses. So LM4040B10, there's a 5 volt, there's a 2.5 volt, there's all kinds of different voltages with that thing. You could also probably just use a tuned voltage regulator, but yeah, it gets a little complicated with like what the grounds are doing and stuff like that. So I like just using bespoke stuff. Unfortunately, I have to have this like going over there, because if it goes under, then it's going to do it exactly what it's doing right now, which is tend to unplug. Has a tendency to unplug. Where are my tweezers? There. A tendency to underplug. And underplug it did. Flip that around and just use it as a thing to push down with. There we go. Hopefully that stays in. It's really annoying when these things pop out. These easy to find 1/4 watt resistors, the 1% through holes. They're good for breadboarding, but they're not thick wires, so they tend to fall out very easily. Okay, is there anything else I need to hook up here? We got our 50K. Oh, output, which we'll just do this way. Actually, I could go like this, yeah. All right, so, whoa, what happened to you? What happened to you, buddy? Output is here. Wait, that's it. Which one is my input coming from? Okay, output is all the way out here. One thing that I've done in the past is go into this trough to use as a routing assistant. there it is. Right there. There we go. So that's output. Output is going through the yeah, okay, let me move the MS Paint over. And we're gonna have to shove a capacitor in here somewhere. Might have been better just to move this out to somewhere else. I guess I could shove it right there, but then it would connect to one of these two. We'll have to figure that out later, I guess. We do this, actually. Well, problem with it is, I don't even know if my cap's going to fit between those two. No, that's actually protected pretty decently. Okay, so we'll do that for now. Let's do one of those. Now, this is where, because doing stuff like this means that I need to like wiggle every single element of the circuit in order to get it to connect properly and actually like do stuff. But okay, oh, we're still doing the LM117. So we hook positive voltage to the LM117, so it's in, ground, out. Nope, in, out, ground. So we need ground here. Easy enough. We'll be able to fire it up in like a minute. It'll be done in just another couple of minutes. So there's our ground, positive 12, and our output here goes up and over. Oh God, it's gonna be sloppy. This is where things start to get messy. I could have done better. I could have hooked 3 volts up to a rail. That would have been, well, then I wouldn't have access to some of these breadboarding setups. When you get into the really like crazy ones, you'll have multiple different rails that you can hook up to stuff. How can I get that distance? It's all this wire. It's all this one wire length. I know some of y'all have told me, like, when you do this stuff, you just have a spool of wire and you're cutting everything to a custom length, which is appealing, although you don't get this red, white, and blue that I got going on here. Everybody salute your flag. Do it now! But it is not my flag, it is now. Let's get this right here. Go in there. There you go. I'll be damned if any of you commies don't salute my flag. All right, so that's there. No, and then that pops out again. This one has been an utter nightmare. Maybe if I do a slightly harder angle on it. Right there. Into the hole. Oh, I could have made that a little longer. Hopefully that stays in a little better. The softness of the bend was making it able to... See, if I plug that one in better, it'll actually contact there, and I don't want that. Okay, so we've got our output hooked up to 3 places. Oh yeah, because we don't have the capacitor in yet. I left a little bit of room for the cap. Just right there. Doot, doot. And we didn't need the 33K because we've got a 100 kilo ohm potentiometer on the whole thing. Oh, no, that's this guy. 100 kilo ohm potentiometer on the whole thing. So what I want to do now is see what the properties of the circuit are. We need to hook it up to power, and then we need to hook it up to a signal and an in and an out, and observe the out on our frequency observing machine, which is an oscilloscope. The origins of the oscilloscope were with an electron gun, and you would have an electron gun that would have a scaled and trimmed and you know, protected voltage level from your probe. And it's basically, the electron gun is moved by magnets, so you have something sweeping the magnetic energy, basically aiming the gun with magnets by sweeping a voltage, and then you would have your voltage going scaled into other magnets that would move it up and down. And as you do that, as you sweep across the screen and you move up and down, the consistency in the frequencies make things line up, and so your phosphor is going, your electron gun is going over the same phosphors over and over and over again, the same paths on the phosphors. And those phosphors are glowing because they have a little bit of persistence in light. So you hit it with that basically glow-in-the-dark material, and it glows, and when it goes away, it starts to fade out, and then it comes back again, and it glows again. And so it builds up that image and you get a line on a scope. And with tuning, with knobs that tune it, you can get everything lined up and take a good close look at a signal that's going by very, very quickly. We apply that to even digital stuff. We have packets that go by over and over again that you can then observe. All right, so the one with red is our output. That's this one. And output is here. Input is here. That's coming from my cheapo frequency generator. Cheapo. And then power is over here. And we have it going through a modular synthesizer IDC connector, which is a insulation displacement connector, IDC. It's your typical computery kind of flat cable. The stripe on it is negative. So the stripe, denotes pin 1, but in modular synthesizers, they like to make the stripe be negative. And the center 6 pins are ground. And then the non-stripe edge of the cable, the 2 pins on the edge of the cable, are positive 12 volts. So now I've got negative and positive 12 volts running to our circuit. We don't have a signal yet. I haven't turned on the power supply. To turn on the power supply, I have to dig myself out. Oh, I finally got a 2.5 and a M2.5 and an M2 screw kit for that tiny RC car. That thing's all M2s. Who uses M2? It's such a ridiculous size. Let's see, I'm going to move these over to the other table. I need them to be present, just not in the way. We're going to use it in this project. Oh, my screen just fell over. So the VCO, the voltage controlled oscillator that I still have to finish up with, uses the RP2040 Xiao. The RP2040, I bought a bunch of these when they first came out and were cheap. I guess they still are. But this is actually going to be what we use for the scope display. And actually, since this circuit is looking pretty small, we might have room. We might be able to figure out the value here and just move this stuff over maybe move it over to here, and then I'll have room for the RP2040 and the screen. I'm going to program it. These circuit projects that have come out recently, these nice cheap electronic things, have really not helped me branch out at all, because turns out we can just program the RP2040 using the Arduino IDE, and an old one at that. So my old crusty Arduino IDE is still working for the RP2040. So I don't need to branch out and learn new things. The boomerification of bother has already started. I'm transitioning into boomer. I'm starting to identify as an attack helicopter because boomers have one joke. All right, so speakers, get out of the way. Move. The thing about the Agilent power supplies, I can also make another reference voltage if I need it. So if we want to make that 2.5 volt reference, we can probably inject it using this other power supply here. So that might be useful to us. Tweezers all the way over here. These are all of the screens that I bought. I'm going to be building 2 of these O-scope modules. Dave doesn't get one because he says he already has one. I really need to clean up around here. This place is starting to get a little crusty. Okay, so turn this on. This one has a loud fan, so I got to turn it off in between things, but it has no persistent memory. So no persistent memory. And you have to turn it on in order to adjust the voltages, which means I probably just should unhook it over here. Just unplug these, turn it off, or sorry, turn it on, and then with the plus 25, I go up to 12. And then minus 25, I go up to 12. And now we're ready to go. Turn it off, bring us back over here, do positive. I should make something that clips to the board and has the connector on it, huh? That would be kind of useful. And then I should probably make an IDC that goes directly to banana plugs. I've got all the stuff to do that. It's just nice when you have like weird helper hardware, helper hardware to make plugging in and out of this stuff much easier. Always wanted to build a synth? Me too. What got me started is the fact that they sell just the circuit boards. The like Modular Addicts and some other websites have just the circuit boards, and you are responsible for building up the entire circuit with nobody else helping you. Because you don't contact the people who design these things, because they only put their design out there for people to build on their own. They didn't put their design out there so that they could provide free support. So you build these things and you're completely on your own, which was very interesting when I got into mutable instrument circuits, because these frickin' things are using the smallest size of surface mount in order to get their stuff done. But I was able to order like a whole pack of circuit boards for like $100 and build up all the hardware on them for a bunch of money in parts that I thought I had but didn't have. And so now we're getting to the part where I'm actually building synth stuff. I'm actually starting to get my feet wet in building actual synth stuff, because I'm learning how the circuits are working through attrition. It's just a war of attrition here in learning these circuits. I mean, so there's a YouTuber, Hajiwo, Hagiwo, Hajiwo. Much easier to spell in Japanese because it's like 3 characters. But Hajiwo has a wonderful philosophy when it comes to building hardware for modular synthesizers. It's that everything should be cheap, right? He builds these things for like $7, $8. Now, there's a lot of support equipment that he doesn't really kind of like list on there, like the front panels and stuff like that. But using like an RP2040 and some clever filtering, you can build like a VCO, right? And so I have taken the Mutables instrument circuits that I think are clean and they work nicely and they do their job really well, and I've mixed them with Hajiwo's cheap circuits that are quick and dirty and work. They're really cool. Like, it's an amazing amount of stuff that I've been learning here. So mixing those two, I've been learning all of the ins and outs of all of these analog circuits in conjunction with digital stuff. And it's helped me out quite a bit. So saw the other day somebody made a PicoPi chip that uses the 2040 and has a few upgrades from the original Pico. That's kind of cool. I made a Hajiwo Arduino-based oscillator. Yeah, it's essentially that's what my VCO is. That's all this is. Pretty cool. But it's instead RP2040. It's still programmed in Arduino, and I had to go through and rearrange and make everything organized in the way I like it. But it's that Salin key filter on one of the op amps that's doing all of the work of creating PWM to audible audio. Valves. I need more valves? There's actually a really cool, what's that? I used to make single oscillators in electronic kits when I was about 8 years old. All those surface mounts look like a nightmare to mount. Surface mount is better than through-hole. It's easier than through-hole. It's much easier. You need a microscope, you need a steady hand. Not necessarily, you need kind of a steady hand. Magnification and kind of a steady hand, and you're golden. But yeah, I need filters for the synthesizer. We've been working on synthesizers for months. I have another project that really needs my attention, though. It's called Burn the Subs. It's a giant XY table that's mounted to my wall, that thing. And we need to get that working. I need to work on that. But I've been putting my best foot forward on that one and burning out on it time and time again. So we're doing a little bit of synthesizer stuff. I'm going to finish up sort of the 3 projects that I'm working on with synthesizers right now. And then we will get into Burn the Subs a little bit more, and we'll hammer away at hardware, get that done like in a stream or a couple streams, and then we can look at some programming, which will basically make everybody leave my stream. Programming sucks. Some people like it. They shouldn't be trusted. Blah, 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 blah. What's going on over here? First off, that's not the output. That's in the wrong pin. Yeah, I get all this stuff right before I flip the switch to turn it on. This is when you catch all this stuff. This is when you catch it slacking. Call you lacking. All right, so according to the schematic, everything should work instantly as soon as I flip this switch. We'll start off with an input wave. So power on. What do we got? Everything should still be set up here. This thing was a cheap frequency. Sorry, Frequency generator kit. There we go. Software engineer pays really well if you're good at it. I'm not trying to be good at software engineering. I'm trying to be entertaining. There's a difference. Software programmers can't be funny. They're not allowed to be. I have to be funny. Watch Code Rush raid me right now. Like, yeah, I've been having a long programming stream. Let's raid Bother. And he raids me and is good. I go, programmers aren't funny. No Clue 321. Thank you so much for subbing for 18 months. Brink GG. Thank you for the 12 months. Hey, thank you guys for subbing. Man, I wish I was back to the popularity where I could like slack off on thanking people and do them in like a batch. Or how about this? Can you guys get me popular enough so that I just don't have to thank individual subs? I just don't do that anymore. I don't think I'll ever not do that. It's shocking to me that people would give me money. It's actually completely shocking, and I will never lose that humble nature. It's impossible, even if people hate it. People like Code Bullet, Michael Reeves. Michael Reeves, yeah, he does do coding. He does do coding. His philosophy is so much different than mine. His work's much better for his comedy videos. Obviously, he has 20,000 views a fucking stream, so I'm a little bit jealous. But he takes big systems and staples them together in order to make his stuff work. And that's all well and good, and it's great when you have it behind like kind of a cool idea. But when I want to do something right and have it work properly, I can't do it that way. I have trouble with doing stuff like that. I need to get down into the bones of the circuit and figure out what's going on and how to make it cleverly and work super nicely. Oh, look at this. I did everything properly. Yes. Yeah, that's what I do. I can't just go like, oh, let me slap this thing together and this thing. Oh, that doesn't work. Let me just do this until it works. Like, no, can't do it. Yeah, things breaking while you're working on it and stuff like that. All right, let's turn this thing on and see what wave we get on the output. I don't know where this potentiometer's set to. We'll just see what happens. So 3, 2, 1, go. Oh, I don't have the thermals on either. Should probably turn those on. Something might explode. Where are they? They should be on. I don't think I turned them off. We're not drawing any current on the negative. Let me check the positive. Yeah, we're not drawing anything. We're drawing very, very little. We're drawing very little. So let me just check out what thermally is happening. The thermal camera is actually really good for this kind of stuff. This kind of stuff being electronics work. Electronics, when they break, tend to heat up. And so if something's going wrong, you can just look at a thermal imager, assuming that yours didn't break like mine did. Hold on, plugging it back in here. Figure video. It doesn't see it. Deactivate it, unplug it, plug it back in. Oh, did this thing disturb the... No, it's still there. Activate. Just doesn't see it. All right, so I think maybe it came unplugged over here. Fixed a TV on stream once, but it was more luck than skill. Don't have the steady hand or any of the right equipment. The right equipment to do... well, to do TV repair, you got to be really careful because there's a lot of power running around TVs. I think I bumped that cable. For anything you do, if you're doing it in the real world and you're streaming it, it helps to have a good idea of shot composition and have equipment that can consistently give you a decent shot composition. Everybody says you can skimp on microphones. I'm not of that mind, but if you're just starting out, obviously you're not going to buy thousands of dollars worth of equipment. So like your average phone is probably pretty good at giving you like a good picture. I don't know, some kind of microphone that's not... Yeah, I think my thermals are broken. What happened to you? You used to be cool. I'm an audio weirdo, so I've done a lot of... This is blinking, so it should totally be recognizable. White light's flashing. No more cries. Cancel on that. Let me just see. There's a lot of very frugal ways that you can do a really good stream these days. It's kind of amazing. There's a YouTuber, the Frugal Streamer, who goes through a lot of this like free stuff that you can put together in order to make a really nice Good stage mic. Yeah, even that might be overkill. Like, you could do a headset mic. Rob Oz uses a headset mic. He uses a slightly nicer headset mic, but still. This thing is a Tram TR50. It's a production lavalier that a friend of mine sent to me. You can also get them for like $100 on eBay. But then I put it through a little bit of audio stuff because otherwise you can hear this. This sounds like so you gotta do a little bit of due diligence. Where did the thermal camera go? There it is. Oh, why is it down there? Wait, that should be up a little bit. Be there. Oh wait, this is the wrong scene for it. Well, whatever. I'm doing this scene just so you guys can see me poking and prodding. Oh, there it is. Okay, we're back. Cool. Thermal camera. I don't know, it must have plugged in weird. Yeah, so thermal imager. I have this to benefit you guys. You guys get to see what heat is doing in the circuit. But this helps a lot to actually show me when my circuit is exploding. Why are you fighting me? Oh my God, the back of this camera is really crusty. I've been handling it for years. All right. Bone saw. Bone conduction, really? New oscilloscope. Cool new feature. Look at that. Beautiful. What the fuck? When did those two get in here? Hey, dickwads. What? It's weird. Flatulent Gonad stream, he has them on like a keyword that'll nuke them immediately. Let's turn channel 3 off because we're not using it. Every time my palm touches the probe, we get that funky wave. That funky beat. That funky beat. If you really like to drop that funky beat, drop that funky beat. Negative. Okay, so nothing is happening. So now we wiggle our components a little bit. Shockingly, though, the negative 10 regulator, oh, it's just starting to get warm. Okay. Oh, yeah, no, we don't have any link limiting stuff, but I will nuke any links that aren't appropriate. You gotta keep them on task. What happened there? What was that all about? Ground to ground to ground. Positive, positive, positive. No current. Not a clean signal. Oh, this might be at fault too. Yeah, this connection right here. I'm gonna do this one direct. We don't really need to co-observe the output yet, unless we're putting this voltage into something else. I'm just going to do this one direct. The BNC extender thing is just because those right angle connectors like kind of threaten to damage my ports. That one's not doing so well, is it? Why are you flipping in and out? What's going on here? Oh, there we go. Okay, that's a bit more solid. Dual link to the PC and phone, damn. So I was thinking, like, if I was gonna ever do, like, not a Mogus, but like some other thing, I could connect my phone to my mixer and then use Discord on my phone for the chat. So the chat would be almost like a separate device. I tend to use a Sennheiser ME66 for stage work, occasionally streams, as they're so directional. That's what Julian has. He's got this incredibly directional mic, so there's like no crosstalk. It's kind of amazing. I tend to use a Jabroni headset just for isolating from sounds coming from something that's covered from the FC. I don't know what that means. I've done a little bit of production stuff, but mainly like festivals and things like that. My senior design project involved a whole stage production. Why are you not doing anything? Okay, so let's double check what we're doing with the circuit. Since our op amp isn't getting, oh no, it's a little toasty. Our op amp is a little toasty, but nothing is happening here. So now we can bring in channel 3 and the probe, and I can probe. Now here's the thing. Since these are connected, we are referencing everything against ground. Yeah, I do have a tablet. The getting chat running on it is not as intuitive as you'd think. I have a tablet that's right next to my the milling machine, and I was thinking about putting chat on it. I would need to make the tablet just do chat. You turn it on, chat would appear on it. I wonder if I could get a microcontroller to do something like that. With a little stream. A little screen, rather. One thing I know, you don't have cold hands. Cold in comparison to this oscilloscope. The oscilloscope, we put a quiet fan in there, and it doesn't quite cool it as well as the original fan, but the original fan had a noise to it. So we had to get noise making fans out of my studio. And so we did that, and now the scope is a little bit toasty. It's basically an Android tablet with a frock. But yeah, by comparison, my hands. Listen, I sit in the passenger seat of people's cars and fog their windows just by virtue of my sitting there. I don't know what it is about me, why I give off moist air. I don't mean to. It's just how I am. It's probably why I constantly need to be cooled. I need to live in a cold Arctic environment. All right, anyway, so we got our grounds on grounds. This one's going to ground, that one's going to ground, that one's going to -12. Nothing wrong with that. This one's going to +12. Okay, and then our circuit totally dies. This should, by all means, be working right now. It's a very simple circuit. It shouldn't be that complicated. I'm a space heater. I suppose so. This one goes to ground. 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 Do I have the pin out backwards? Let's see. Output is right next to VDD. VDD is positive. Positive is going to 3-volt out here. We've got an LED on, so our 3-volt is outputting. That is going to the correct pin. Yes, it is. And then the pin right next to that, VDD, is minus. Backwards. No, minus goes to... Oh, those are going to plus. No. Output minus. Minus is here. What is this? This is input. Oh, output rather. Okay, yeah, that one is output. That one is correct. That's output. Between input and output, we have. Let's pull up the microscope. I got to check over my work and look for any stupid little mistakes. So, VDD going to output here, out. Double check that with a scope probe. That is 3.3 volts, solid. I'd turn on the scope, but it'll block a bunch of stuff. So 3.3 volts coming out to here, confirmed. This one is ground. No voltage potentials there. That one is confirmed for ground. The thing is, I'm hooking this up with these BNC cables. So what that does is that takes the ground all the way out to the scope. So the scope's already grounded, so I can poke it with a single probe and see what's going on voltage-wise. In reference to ground, you got to remember that. Here's the scope. So all this is in reference to ground. 3.3 volts right here. Boom. Boom. This one should have a signal on it, and it doesn't. So what's going on? There's signals coming in on this 3-pin header. One of the pins goes all the way out to this end of this connector, and the other one is one end from that. Is this where our signal is? No, our signal should be here. There it is. See how it turned purple? What if it was purple? And then this one is ground. So on the purple wire, we have a correct signal. This is a 100 kilo ohm resistor that is not picking up the signal. What? 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 Why would you do this? There? Not there. I mean, I guess it's just so small we can't really see it. But it is plugged in here. Oh, hello? 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 Are you there? Hello? Oh, why is this connector loose? Hold on, tighten that up. Connected at both ends. Yeah. And like here, we can see the signal. Why is that? Why are you fighting me? That's this little adapter out here that's fighting me. Come on. Ugh, T-junction. Hold on. This thing. This thing is making me into a fool. Let's get this one over here. Swap out the hardware and just see if it's a hardware thing or what. Signal input here. Oh, that's kind of a little super tight. Why was that super tight? Yeah, I think it's the three-way junctions are kind of a piece of shit. Like if I'm pushing on it, it'll make a perfectly fine connection, but then when things move at all, they fail. It's just not springy enough. All right, hopefully that leaves us alone for a little bit. It's all on the connector. It's just the connector being a little wonky. Because as I move this circuit board around, the connection's being moved. So anyway, here is a slightly, I mean, you can kind of almost see it. What are we, X1 or X2? We're on 1X, okay. So if I actually up the scale on it, lower the scale to millivolts, you'll probably see nothing? What the deuce? What's going on here? Oh, that's all the way down at -10. There's -10. It goes through 100, 200K to here, where for some reason it's nothing. And then maybe if I adjust this 100K either direction, nothing happens. What the all right. Fine. See if I care. Why are nothing? Negative is connected to ground here. Okay. Negative is connected to ground. This one should be output. Oh, there it is. There it is. Okay. So, and then we've got the blue trace is probably, yeah, it's on a different voltage scale. Although to be fair, like, we're not seeing it outputting. Why am I getting an output here and not actually at the connection? Yeah, there's the signal. It's not coming out of this. Whoops, what did I hit? Close the window. Yeah. Damn it. There we go. Touch screens. This fucking thing. Look at this. Oh, good. There's nothing going on. There's nothing works. Nothing's happening. Wiggle everybody. Wiggle these. Wiggle this one. This one's a piece of shit. They put like a rubber band around it. All right, now we see our input. Okay, that was supposed to be super reliable. It's just cheap BNC hardware has been annoying. So the blue trace, look at the properties of the blue trace. Display on, channel 2, not on fine. Scales 1, offset 0, coupling DC, unit volt. Don't need a label. Yeah, all that's good for basic use. And then we've got 3 volts all the way up here, which by all means I should be able to access. And for some reason, it's just not outputting. When I pick up on the voltage here, well, that's fine. What the heck? Yeah, so I've got control between 0 and, well, that's less than 2 volts. But for some reason, we're not seeing it on the channel itself. And then when I moved that, I bumped this one little wire, and that's all it took for this stupid BNC connection. Why don't you go all the way over there? You just go over there, deal with your own shit. I'm going to deal with mine. All right, this thing's pissed me off. Let's try swapping out adapters here. Adapter's a little tighter. Yeah, the plug on this BNC is really annoying. Is it like a bent wire? This thing's not making contact? I don't know. Just like the size, the size they built this thing in. Look at that, it like cuts out. The fuck? Not a big enough spring or something on it. BNC hardware is a little expensive to manufacture, and I guess they cut corners until they're just barely under what'll make a successful product. Man, this thing's hot. That's not that bad. All right, please just give me a signal. Ugh, dealing with stuff like this is always the worst. What about element 14? Why do I only get a signal like for a split second? This sucks. Look at that. Give me this back. Why are you bad? Why are you so bad? Why is this one so bad? What the heck? What the f... Okay, alright, alright. Whole thing's gone. You're gone, you're gone, you're out of here. I don't need new wires. The wires aren't the problem, it's the BNC connector itself. It's the splitter that's being a little bit weird. So, different hardware. Still a little bit weird, but a little bit more stable. What? BNT? It's dynamite. All right, so now that we have a signal, we still don't have a confirmation of output. It's just a little bit less obnoxious for me to work with. Let me move this out and away. I usually stuff the cables under the scope, but the new scope doesn't have that much of an under surface to it. Exhibit A, parallax. Parallax and breadboarding are not friends. There it is. Now we don't need channel 3 anymore. This is the simplest of op-amp circuits, so I mean, you know. So when this thing is all the way to the right, all the way to the right, that would mean that this is at 100K. All the way to the left would be 0. So our input is having a little bit of trouble. It's not going out of boundaries at all, which is good. What scale are we at? We're at, yeah, 1 volt per div. And so we're not getting all the way up to 3. We're not expressing our full range. Now, then again, our signal is going from, oh, wrong one. So 3-ish, we're at positive and negative, 5 volts. We're going 5 volt peak to peak on a 300 hertz sine wave. 5 volt peak to peak, 300 hertz sine wave. 5 volt peak to peak should probably get us to within our full range, shouldn't it? I mean, that's mathematically how everything came out, but again, depending on what this stuff is doing, what the physical circuit is actually doing. I know this is somewhere around 90 ohms. Oh, even touching it makes it buzz a little bit. So if I give it a 100 kilo ohm pot, it'll go from saturation, and there's range at the very beginning of this too. So maybe I just give it a singular 100 kilo ohm potentiometer, and that way it can go from totally blank to very, very quiet to what is ostensibly our full range here. That may be what we do. 100K makes it a lot easier. I'll have to order a couple 100K pots, though. I only have this one in this flavor, in this through-hole flavor. All right, so now I want to actually bring it up in frequency, and I want to see what happens when we actually bring the frequency up. I don't know what this frequency generator is capable of, but we can put a sweep through it and see what a sweep does. Yeah, these are various waveforms that I can do, but not what we want. Wait a minute, what is that doing to what? Is that inverting it? I guess it is, yeah. Right, so in the software we need to revert it. So mode, continuous wave, sweep. How do I hit OK? Escape, there you go. But there's no sweep controls. Mode, sweep. Is there there's an escape key, there's a waveform key. Kilohertz, offset amplitude, FT mode, and a power button. Do I just wait? Do I just have to wait for it to initiate? That's what this is. See, we got a potentiometer is a variable ohm resistor. It's just a knob that has a bunch of resistive material. It goes from thing to thing. This isn't engaging it. How do I hit OK? Go into sweep mode. Do it. Like I can hit escape, but then it's not in sweep mode. Weird. This thing is a kind of a strange little guy. There we go. I had to hit mode again. Okay. So now we can see the frequency response of this thing. Up to, start is at 10 hertz, 10 to 5,000. So let's zoom in on that a little bit. And what we're watching is to see if it has the frequency response that we want. Now the Arduino is only going to be able to sample that waveform at certain intervals, right? As it sweeps up from 10 to a billion hertz. So we want to have a little bit of a dropout at 9 kilohertz. So let's go to 1,000 hertz. Sorry, I want 100 hertz. Oh, escape. Oh, that's a delete button. 0, 0, 0. Now we're getting into it. Look at how high that goes in that frequency there. We're zooming way in. Let's center this.
We're actually taking advantage of the frame rate of this thing.
That is beautifully stable at that high frequency. Well, 100,000 hertz is not a crazy high frequency still. But we want it to drop off at 9,000. Was it 9 kilohertz? Hold on. Just so that the high frequency noise is not present in our... I'm shocked about this little frequency generator. That thing's quite useful. Oh yeah, my latest VOD. That's my latest VOD thumbnail. Little Willow over there. He was in puppy jail during that stream. I had Conan hair that day. Okay, so let's see here. We want to go up to a billion zillion hertz. No, we don't. Where is my... Oh, that was snipping tool. There we go. So we want to go up to 9 kilohertz. There's probably a way to math this thing out. 9 kilohertz. But let's just try to put like a capacitor in there, because what's supposed to happen is, as we get into higher frequencies, a capacitor that is parallel to our feedback resistor will cause there to be stronger damping, and it'll sort of turn down the volume knob on our high frequency. So what we should see during the O-scope sweep is we should see this waveform getting narrower and narrower. I'm actually going to make it the size of the whole thing. We're going to do that. Whoa, like that. And then channel 2. I'll keep them in comparison to one another. Yeah. Oh, channel 1's at 3 volts. Wait a minute. There. Oops. So yeah, those are now on the same scale. Yeah, breadboarding, I've found this to be very refreshing and fun, because over the past couple weeks we've been doing these circuits and, you know, building them up, and there's been testing with the O-scope and everything, but like the breadboard makes everything just that much more agile, so that you can just sit here and throw stuff at it and see what sticks. What I miss is I got rid of, many years ago during a move, I got rid of a bunch of variable capacitors. And all variable capacitors are a bunch of plates that are funnily shaped, so that when you twist it, the plates will be parallel to each other more or less, and they'll vary the capacitance. They were so cool, and I don't know what I did with any of them. I don't think I got rid of them. I had to have put them somewhere. So we're talking about either 18 pico or 9 nano. Well, 9 nano, we can get 10 nano over here. These are pretty accurate capacitors, I think. I don't know. I've salvaged hundreds of those from test gear. They're all in one drawer. I held on to them for so long, and I just wish I knew where they went to. Because I just don't know. I wish I knew. So now we have an 18 picofarad capacitor in there, and it's totally killed our output. So that was a 10 nano. We go down to 2 nano, and then we're going to have to go to specialty stuff. I think I just flipped one of them into a different bin. So I don't know why 9 nanofarad made it into any of the designs, because that's way too big of a capacitor. The cat fiends. The cat fiends are in town. Everybody hide. So I started playing Fallout 4, New Vegas. No, just Fallout 4 last night. Actually, the night before last. I don't think I'm ever going to see the light of day, because that game is addictive. I think we need a much smaller value. We're damping even at the very beginning of this. I fell out of bed last night. All right, well, that's good to know. Here we have one nanofarad, but 1 nanofarad is way bigger than a picofarad, so I think I need to actually solder in picos. Oh yeah, New Vegas, Fallout 4 also has that too. All of the Fallouts, because it's such a heavily modded game, you can get complete conversions once you sift through all of the frickin' naked bodies that are on Mod Nexus. You really do have to sort through them too. They're obnoxious. So what is that doing to our waveform? I don't know. I don't really think that's doing much. It's just kind of killing it. Hey, yo, I'm feeling it. Tachyon. Okay, we got to get a smaller cap here. Or do we just not filter it at all? Radio sounds like a fun project. Yeah, I've been installing mods, but it's just like I want the Bozar, and I want from Fallout 2, and I want this, I want that. Give me storms and nuclear radiation storms and stuff like that. And then objects that don't fly off of a table when you pick something up. I can't believe Fallout 4, even in 2015, Bethesda did not solve the problem of pick something up off table, everything on table flies away. It's a pretty crazy thing to not fix in a game that stresses building now as part of a mechanic. Because when you build, you have to do what Roboz calls the krimskrams, which I guess is a Swedish word. Just the stuff that makes up all the surfaces and the little things that tie everything together. Because if you don't, everything looks very robotic and unlived, and you want things to look lived in. And in a game that's all about that, they didn't fix the error where if you touch a fork on a table, everything on the table goes... Yeah, there's one for Fallout 4 too, it like locks stuff down. You were a beta dev tester for New Vegas. You worked at Black Isle Studios. Pretty cool, man. That game has found a huge popularity. People are discovering how awesome it was. That's the first one, the first Fallout. Well, the Fallout that I used to fall asleep the most to. Because I fall asleep while playing it because the desert ambiance is just really good. But I cut my teeth with Fallout 2. Fallout 2 was my jam. We're setting up to put some capacitors in here, so I'm going to get a couple of these mounts so we can just put this aside. I accidentally ordered way too much of this stuff. The holes in the top here are too small, so in order to utilize as much of it as possible, I use it as a through hole, sorry, an adapter for surface mount passives. I dabbled with Wasteland, I dabbled with Fallout 1, I did not play them for very long. Fallout 2 was sort of the sweet spot for me in terms of like the references and the humor and all that fun stuff. Because I like the silly stuff. We're looking for 9 nano. Or no, 18 pico. I have a book of capacitors in case we don't have that, but we do go down to 12 pico. So we'll try 12 pico and see what that does. Yeah, I hear good things. I just never got into them. This one is huge. It's an absolutely enormous capacitor. It's a 1206. Jeez, what was I thinking? Maybe I'll have to go into the capacitor book for this one. If only you guys could hear this waveform. So annoying. That'll fit. 1206 will fit. I'll make it fit. I'm the fitter. I'm the one who fits. I could probably use the big dumb solder for this. We'll use this stuff anyway. Yeah, so I never had that perspective because I came to Fallout 2 in like the days when people were playing like Shogo and stuff like that. So games were already very 3D by the time I got to Fallout 2. I would imagine at the time like DOS games looked like really, really hard to see pixel art. Were the Sierra games under full swing at that point? Because the Sierra games I did play a lot of. Indiana Jones and the something something Atlantis was a big deal. Although it was on Mac, because at that point we had Macintoshes. So I didn't get to play all the hits of the day. You get to play all the edgelord games that were parodied in the follow-up to Hypnospace Traveler. And if you guys are from that era, the DOS 3.1 / really, really early internet types, you might check out Hypnospace Traveler. And I won't say anything else about it, because the game is absolutely brilliant. Parody of that era of time. And then the follow-up was, of course, the perfect parody of the boomer shooter genre. Not even a parody, though. It's just a parody of a personality. You guys can't see the heat because I got the schematic up there. Let me close the schematic. Well, no, the schematic lends itself to the rest of this design and what's going on here. It helps you guys contextualize everything. But you can't see that I'm about to burn myself on this capacitor that I just soldered. Did it weld itself in there? No. Okay. So here's the junction of that potentiometer. The potentiometer just goes across the entire input to output. So instead of having a 33K and a 50K, we have a 100K. You haven't heard about it in forever? I still watch the Tomato stream of it. So now we put a picofarad capacitor, well, what did I grab? 12 picofarads. What this should do is at the higher frequencies, it should be tamping down that signal, but it doesn't appear to be doing that. It doesn't appear to be doing much anyway. At the lower frequencies, I can see it narrowing a little bit, but it's narrowing on that voltage level. It's not being a low-pass filter. Like the function that it's supposed to provide in this orientation is keeping higher frequencies from getting through your audio. Let's see if we can go higher frequency than that. Let's just go to like 500 kilohertz. I mean, what it seems to, it doesn't seem to be doing that much limiting. You can see that the op amp is unable to get full. You can see the op amp is actually narrowing that voltage level. Let's turn 2 up a little bit and let's just see if we can actually see the effects. I think that's more of a result of the frequency than the capacitor. Hugo's house. Day of the Tentacle was one of the big ones when I was a kid. So see there, it's not dropping off. It's only dropping off when the main signal drops off, which is around... Actually, it doesn't tell me what frequency it is. Well, we're out of the range of audio anyway. So I don't think the capacitor is going to do anything there. Let's go back. Let me go back to one of the big guys. Let's go with a... 0.018U. Try it. We have to solder it though. We'll go with a much larger value and see if there's more of an effect. Oh, there's nothing in that box. That's in, oh no, there is. Slide. Try this one out. How are we doing? Everybody's good? Yeah, everybody's good. Dog's barking at stuff. Doggy is barking. I did a video of her barking yesterday. You guys get to see. That's how she treats people. When she thinks there's somebody there growling at them. Giving me this weird look while she barks. That the little den of hers, that's under my work desk. So when I'm working on like what I was doing is actually working on this schematic and figuring out what exactly I was doing in the circuit. And she was sitting there at my feet in her little bed, barking at things. What? I need more solder on this. What the heck? She's really going at it. There's probably a friend of hers outside. She knows more people than I do in the neighborhood, and I've told this before. Like, I've had people come up to me and be like, "Oh, hey, it's Willow," and I'm like, "I have a name too." I don't even know who these people are, and they know who she is. The thing that I'm working on training her on right now is she gets mad, like play mad, at feet. Well, sorry. When you touch her paw, she will play bite you. And sometimes it's a little harder than a play bite, but it's always just like a, you know, not like an actual dog bite. It's like her just playing around. But when she's playing around, she's being a little bit rambunctious, and I got to stop her from doing that because she did that to the vet once. And obviously the vet didn't appreciate it very much. And it's not like a violent thing, but she makes this very guttural growl. And so I've been trying to train her off of getting riled up when you poke her paws. Basically, the philosophy should be like the friend of mine does, where he will hang out with the dogs. When he does, he'll poke them and prod them, and like, you know, oh, pull on her ear or something like that. Not like meanly, but just like little annoyances to get the dog used to like being handled and prodded, so she doesn't get aggressive at the vet. Some dogs are really bad about that. And Willow's really good about that, and as soon as you tell her like she's doing something bad, she'll listen to you. She's smart. I'm gonna let this cool off for just a second here. I'm impatient. Owie, I should have been patient. What the heck? Why is it so like welded in here? Jeez. That means it'll make good contact, I guess. Oh, what happened there? Wait a sec. What the heck? Wow, I really made a hash of this one. Let's just see if it does anything. So this is a much larger value of cap. Oops. Get out of there. Well, that's just limiting the whole thing. Yeah, it's just turning this into a voltage level. I mean, really, so the original circuit asked for a low-pass filter with two 1 kilo ohm resistors. The capacitors, I don't know what the values were. What were the values of the capacitors here? Go back to Hajiwa's circuit. We can make a low-pass filter very quickly using resistors and capacitors. Good doggo. I don't know. 22 nano. $103J100. I think these are 100. So let me put these away, and then I can get 22 nano from this kit very quickly. I think this doesn't. This is 10 NF. What are these? 103. The first three digits. 103. Okay, so these are 1 NF. So let's get 22s. These. .22s, and then we'll see what value these resistors are. I think they might be 1Ks. We'll just build Hajiwa's filter. I want to see what it does. You just can't see anything. That's all. I'm looking at this waveform. That's all I can hear in my head. What are you? 1Ks. Okay, cool. So we can make our filter out of this, and I can put it wherever I want because I'm a big boy now, and nobody can tell me what to do. I'm a big boy. Nobody's going to tell me to build my circuit where I don't want to. Nobody. My circuit. Here's the grass. He doesn't even see code anymore. Blonde brunette. I've just sat there in a lab with a sweep going on out of a speaker for way too much of my life. So what I want is one connection to ground on this. I want to see what the effect is of isolating this from ground. Thanks, that's all I hear. I suffer so that you can suffer also. And then our resistors are... I've been here with you a few times. Yeah, like when Julian's here. I'm going to start out with my modular synthesizer thing. And I'm like, stop it. You have to stop it. This is illegal. And he's like, why do you hate that? You guys have to do the little at the end of that. 22 NF on the first and second one. We'll worry about that next one later, the 470. So those two, and then those wire up to one another. How is this going to work? I'm running out of screen space. So, right, okay, wait, hold on, no, that's not, wait, over, okay, I can't, there's too many things on screen. I wrote one in GW Basic, what's that? Back in high school, I had to cycle up to ultrasonic and back to barely audible. Ran it, left class. Oh, ugh. All right there, Satan. I don't know why the musicians don't hear the repetition and how annoying it is. There we go. Look at that. That's a lab setup right there. That's what that is. That is a lab setup. You got to get the Steel Series does not send me mice, and they should really send me a box full of mice for all of the contributions that I've made towards advertising them as a normal and functional mouse that doesn't fail completely in a couple months. It totally doesn't do that, and I don't have Stockholm Syndrome. I do not have Stockholm Syndrome with SteelSeries. They don't keep betraying my trust like other mouse companies do not betray my... Wait a minute. They keep dying on me, and I don't know why. I had one of my SteelSeries mice actually machine itself from functioning. There was the scroll wheel would machine away its own material. And I keep buying them for some reason. I don't know what's wrong. I think I got like a brain worm or something. I think my brain's got worms. All right, let's cross these over. That way they'll look like they're at least going somewhere functional. Oh, they're not big enough to cross over. Well, I can stretch the leads a little bit. I don't like doing that with these, but because these go so cleanly into a perforated board. They're so clean. Whatever, this will look a little bit more like the filter that it is. So, and then our output, all the way over here now. So what I'm going to do is I'm going to take this input. Whoa, our waveforms all over. Oh my God. All right, I need much longer cables for this. Much longer wires, which means I got to get the wire kit. Where did that go? Did they put it away? No, wait a minute. I must have put it away. It's back in the bin. Grab it back out of the bin. Where did you go? Wire kit. No, it's out here somewhere. Where did I? Oh, there it is, way over here. Everything's within reach. On IBM PS2s. GW Basic is a dialect in the basic. Oh, it's a basic. Oh, like basic, like all caps basic. Oh boy. Developed by Microsoft from IBM Basic A. Functionally identical to Basic A, its basic interpreter is a fully self-contained executable and does not need the cassette basic ROM found in original IBM PC. It was bundled with MS-DOS. It was bundled with MS-DOS operating systems on IBM PC compatibles by Microsoft. You can see my brain was actually falling asleep in the middle of that. And I was unable to make the words. The words were not forthcoming because my brain was like, I'm dead. I had a good run. Has a brain. A lot of chemicals. All right, so there's output. And now input, probably the same, yeah, same kind of wire. Replaced by Q-stepping. Oh wait, no, the output's coming from over there. I can do a shorter wire for that. I can use this one. And I will. And I will. You can't stop me. None of you can stop me. Where is the output? That's on that one. So I need to go like this. Bonk. Okay, so there it is, unfiltered through two 1 kilo ohm resistors. I'm barely even getting a waveform anymore. Get this out of there. Oh, there we go. A cap was like screwing it up. Okay, so we're now plugged in from input to output. So that's these two wires going in and out. And then we have a 1K and a 1K. And so we're looking at the waveform, and it looks unperturbed by the 1Ks. Let's take a look at it without the 1Ks. So without the 1Ks, and I'm looking at amplitude here. Damn it, why are you fighting me? So let's get this back on scale. Yeah, that would be the same scale for these two. So this is the original output. The Eurorack from Mordax Data. That's a $400 module. This is a $7 Arduino project that happens to be able to also display waveforms. There's a huge difference between the two. These these resistors are a thorn in my side. They're so annoying. Because they have these tiny little wires coming out of them, right? And they don't make contact at all. Look who decided to join us. It's our original waveform. I'm actually going to turn that up because we're interested in the comparison between that and not having those two 1Ks in the path. I don't really think there's much difference. Okay. I thought there would be. I could probably characterize it if I actually put measurements up on the screen. So there's it without the low-pass filter, and now when we add the low-pass filter, which is done by grounding these two capacitors, this is also, I don't blow up an RP2040. That's the main purpose of what we're doing here, is we are trying not to blow up an RP2040, and some days it's harder than others. There's it with the low-pass filter. Now we look, we've got similar results, actually, to be honest. Yeah, these are film caps. They're accurate capacitors. So, I mean, it looks like that filter is totally killing our audio output. This is what was called for in Hajiwa's circuit. They seem to just completely kill it. I mean, we are on those low frequencies more often. What the heck? Why was that even the thing? Hate. Let me tell you something about hate. If you wrote hate on every single atom of these fucking resistors, it would not even begin to describe how much I hate these resistors. And their stupid little thin wires that come out of them and don't make contact with any part of my breadboard. Oh, they're not connected at all. That's usually the case with stuff like this. Yes, I'm having a Harlan Ellison moment. I actually always found that to be a little bit cringy. Like, I don't know, nobody could ever deliver that line that would convince me that somebody was that mad. And it was a little too verbose. A little too verbose for me. But hey, I have no mouth and I must scream is a very popular thing. People like it. What up, Bubby? Man, my dog's name is unofficially Bubby. She's a bub. She's a little Bubby. The book, I have not read the book, believe it or not. I played the DOS game, and I know a little bit of Harlan Ellison, not a lot. This might be the problem. So what happens if I then cut off the ground? Our wave is back. Yeah, the old adventure game is hilarious. I love it. It's totally different from the book. Oh well. I'll have to get on like audiobook or something. Why are you doing this? Why are you doing this? Oh, hey, I'm glad you're here. Please work. Well, oh, wait, I don't know. I don't know if it's working, to be honest. What is this doing? Because, like, both our capacitor on the op amp and this thing, I could actually just do this. I could just double it up. Well, okay, maybe not. My waveform. My bones. Hold on. Just going to make this a little bit flatter. Stupid thing. Okay, so we're trying out the 9 kilohertz low pass filter, and I'm seeing if I can get the same performance out of a capacitor across the op amp. Those are actually the books that I got in the 90s from Radio Shack, which, here, if I do this command. Oops, hold on. Those are what started me out. Yeah, there it is. The Forrest Mims manuals. Although, to be honest, nowadays, like back in the day, they like, oh, you want to start out in electronics? Well, here's a 1 to 10 transformer with a couple wires out of it, and I would like you to plug that into the wall. That's your first project. Like, it was unnerving how many times they wanted you to plug a goddamn transistor or transformer straight up into the... Oh, okay, so this is also what's going on here. This is why it's not working, is I'm off by 1 again. They would want you... The number of times that they'd want you to straight up just plug a transformer into the wall with no fuse, nothing. Ah, there's a circuit breaker on the circuit. They'll be fine, little Timmy. Just completely unhinged. And it's no wonder this hobby didn't take off until they started making everything low voltage and digital, because everybody else was dying. I guess I just have to move this out. I'm gonna move it out instead of in. There's too many elements here. I'm trying to build the filter as it's drawn. Give me this. Giant meaty fucking hands can't. There we go. You go in there. Yeah. And now, it's not really doing all that much different. Because of these stupid. Just make a connection. So I'm just not seeing the amplitude on this on the outset, on even in the low frequencies, which is weird. Because we're starting at 10 hertz and we're talking about audio, so we're dealing with something like what, 20 to 20,000? 20 to 2,000? Well, it's supposed to be getting rid of the lower frequencies. I just don't see it doing anything. Here it is without that filter. You can see it immediately jumps up and starts functioning properly. So I don't know what you're smoking there, Haji Wo. I don't know what's going on here. Unless that's 2.2 and I accidentally put in 22. Let's try 2.2. This is the utility of breadboarding stuff. Half Nyquist, whatever your sample rate is. Yeah, and I haven't done any of those calculations. I don't know what our sample rate is on the Pico Pi versus the Arduino Nano. Arduino Nano is getting a little bit old, so. The kit I had used springs for the wire connections. I used to have one of those. There was, I also used to have, and I wish I still had it, a big breadboarding console that had, it was all, the whole thing was tilted. It had all these different sections on it. You had switches and knobs and stuff. It was great. That would have been really good for this kind of thing. This one was a 22. We're going to try 2.2. The good thing is all the values are just printed directly on these, so you know what you're putting in. Oh, God. No thanks. Just sign me up for a DAC. I'll just buy an audio DAC and throw that in. It's too much math. We're allergic to math. So that, now it's a 1-pole filter. This is with a 2.2, not a 22. Now it is a 2-pole filter. And we've got all kinds of weird noise. Good, good, just what I wanted. I love weird noise, love it. Love it, love it. Why is there weird, stupid noise on my thing? And then, like, it looked like it was working, and then it just stopped. There it goes. Wow, where is all that noise coming from? It does appear to drop off, though, a lot faster. All my amplitude control does at that point is just do, like, a voltage level offset. That's weird. I guess that's not really working the way that I was hoping. Strange. So if I get rid of the filter. Oh, that's new. What the heck is going on? There. Okay, so that's nice and clean. I just had to wiggle these things up here. So if I reconnect my ground down here, all that noise comes back in. What the hell? That's an analog oscillator models, sorry. Band limited impulse train or discrete summation formula. Band limited impulse trains. Man, those are crazy. We worked with, last week, we worked with a PWM to audio wave thing, and it used a Sallen-Key bandpass filter in order to create the audio wave from a high-frequency PWM. I don't understand. The description of what that capacitor is doing is to prevent ringing. The capacitor that goes up here in the op amp, and from what I had it described to me as, is what it was doing is at the higher frequencies, it was like damping, or it was acting like a more a less amplified circuit. My brain's doing all kinds of weird stuff. It would basically turn the volume down on the high frequency stuff, whereas over here with our low pass filter, I'm trying to listen. I'm talking quickly. I'm babbling. I'm trying to choose my words correctly. I got to pause to figure out what the hell the 3 types of filters are, and then figure out which one we have and relay to you the right information. There's a lot going on in my brain. But like this low pass filter is not doing shit. Yeah, Sallen-Key bandpass apparently. The way I describe it is it basically plays a game of Flappy Bird with the waveform, so that you punch it with a bunch of PWM, and the filter is just smoothing out those punches. But the punches are essentially like energy levels. And so as it hits the Flappy Bird, as it hits the screen, the Flappy Bird goes up, and then as the filter does its dirty work, the Flappy Bird goes down. And so it does that in order to make like a sine wave. So I introduced the filter. Okay, that looks a little cleaner now. That looks a little bit like what we should be seeing, except that it does it to a voltage offset, which is a little bit strange. I haven't played with sound and keys outside of that application, so I do not know. So okay, we can see what the low pass filter is doing. It's allowing the lower frequencies to be louder, basically. Lower frequency louder, and as it gets louder and louder, it gets narrower and narrower, and this DC offset wouldn't matter if we put it through a capacitor and looked at it that way, because then it would look similar to our input voltage, which is on the yellow trace. So how do we get that performance out of the feedback resistor? I turn this off, boop, I'll connect this directly. All right, so we're directly connected. And now we have the junction right here of our, whatchamacallit, we have the feedback resistor of the operational amplifier, and I punch the component right into the feedback, right in parallel with the feedback resistor. This is barely making contact, but it does not appear to be doing anything to damp the signal. Keep in mind, we're going up to such a high frequency that you can see our OG signal is actually getting more and more narrow as the oscillators are unable to actually catch up. So whatever that value would be filtering out is not happening. This one is an order of magnitude different, but I have this weird feeling they're not making contact with the pins. But you can see it happening there, but it's just limiting the lower frequency stuff too. It's not as clean as that filter. So maybe we do need to implement the entire filter, the filter in its entirety in the oscilloscope circuit. All right, well, that's a conclusion. I guess that's enough of a conclusion, right? What do you guys think? There's this beautiful competition for headroom, the signal versus the filter. Well, I can, I can make them comparable too. I can actually do just like that. Wait, what am I doing? That's the wrong thing. Badoo, magic gold. There you go. Input versus output. Though technically we should be able to double the signal, which is, I don't know what's going on with it. Well, we're not giving it a full 5-to-5 swing. And the only reason this thing is doing the gain thing is because it's running out of it's the signal generator. But then if I give it this filter again, you can see how it damps down those higher frequencies. And there's still a 470 PF. I don't think I have, I don't really have a 470 PF that I can put in like that. Let me make one. I want to make one. Is it all the way over here? 470 pico. Let me see here. Right, and I was trying to get the same thing out of the simpler topology of having the feedback capacitor, which is something that a lot of these synth designs do for their outputs. Actually, for the inputs. What if you like bread and boards, but you hate breadboards? Well, then you're in good company, because I'm getting very annoyed with these super duper thin resistor leads because they're so cheap. Let's sell these to everybody. And so now you can't find thick leaded resistors. I remember having to go to Radio Shack and spending $5 for 4 resistors, like 4 through-hole resistors. It was hell out there. Now you can spend $5 and get a kit of 10,000 of these things. So that's good, but at the same time, you don't have these big leads. And so this this breadboard is designed for big leads. 470 pico. 47p. 4700. I don't have 47. 0.047 UF. I think that's not going to be, that's going to be like nano, like 47 nano. Quarter watt resistors, they have chonk leads. Yeah, but the problem is if you browse the cheap stuff, which is where I live, you don't get those. And I tried to order a whole kit, and they were the wrong size. 4700, I have two things of 4700 picos, 3327. Let me get the capacitor kit. I have one of those sample books of caps. These sample books are the best when they're actually accurate. They really organize things. I need like a bookshelf that I can put all this stuff on. So, capacitor book. There's still no real estate. Anyway, these sample books are great. They got everything. And they keep them nice and organized. So we're looking for 470 pico. 270. 470, it's right here. And there's a lot of them missing, huh? It's a fairly popular audio value, huh? What's up, Speedy Cat? How you doing? Okay, I'm trying to get this thing out of here. There we go. Jeez. I thank you guys for the follows. I see a bunch of follows. I've been trying to be more prolific on Twitch. Saying hi to buddies. 470. These are 470. Where's 470? Right there. And the problem is if you put the wrong value of capacitor in a book of capacitors, like you accidentally get one off by a little bit, which is what happened with the book of 0805 resistors. I had values that were wrong. But if you get the wrong resistor, you could just see that it's the wrong one, right? If you get a wrong capacitor, nobody's going to ever be able to tell. I don't think anybody's ever going to be able to tell. Unless you're doing stuff like this. But most of the time, when we use capacitors nowadays, we're making filters. We're just trying to make like noise filtering and stuff. Nothing too complicated. It's not really like a 470 picofarad capacitor is not going to make or break your circuit. And so you'll never know. Maybe you'll get slightly degraded performance, but you can never tell because you're just a hobbyist and you don't have all of the spectrum analysis equipment that might be necessary for such a thing. By the way, we could do an FFT with noise. Actually, wait, can this... Might be able to... Yeah, I might be able to do that. Hold on, we'll try that in just a second. Let me just get this 470 PF on there. If I can create noise, then we can observe the noise with the oscilloscope and we can pick out the frequencies and see what the amplitude of the different frequencies are. And that's called fast Fourier. Well, it uses a mathematical principle called the fast Fourier transfer. That's why we call it FFT. And that'll allow us to see the frequency breakdown of a signal. Very useful tool. What's up, RYG? That is some of the most frustrating things. You know, your brain is default wired to hiccup. Your brain is default wired, just let that sink in. Your brain's normal state is hiccups. And there's another part of your brain that evolved later that prevents them. How accurately can you measure the capacitance? I've got a decently accurate LRC meter. My multimeter does not do capacitance. But I do have an LRC meter. And that was actually pretty cheap, and it's pretty accurate. Like, decently. It's not amazingly accurate. You know, you get into scientific equipment, and things start getting ridiculously expensive. You don't want to know my brain's normal state. So, this has a 470 pico that's permanently wired to ground on the output here. Wait, oh, my leads are, okay. So that, okay, what the, so 470 pico here, and then I just need a ground wire there. Tweezers, there we go. Tweezers go here. This one does not get activated or deactivated with the microcontroller pin. So there's a couple things. Generally, for me, I do breathe it. Like you hold your breath, right? Take a big, deep breath, let a little bit of it out so it's comfortable. Hold your breath for a long time, as long as you can tolerate, and then don't let it all out at once. Very slowly let the breath out. Very slowly. And what you're trying to do is let it out in such a way as to calm your diaphragm the fuck down, because that is kind of what's precipitating this whole reaction. And so you calm that diaphragm down and it stops twitching. And the longest output breath that you could manage while not having your body throw itself into a panic for not having, well, it's actually at that point, it's not a panic for not having oxygen, it's a panic for having too much carbon dioxide. We're way more sensitive to carbon dioxide than we are to the amount of oxygen. Okay, so we've put that filter in there, that 470 pico, but it's not doing anything right now because we're not hooked up to it. So I need to grab this line and bring it all the way over to here, put it on the output, and we can see what it used to look like. What it looks like now, it ruined it. What the fuck? Why is this okay? Well, it's your brain detects too much CO2 more than it does lack of oxygen. Yeah, there was that person that had like carbon monoxide in their apartment, and they thought that like their ex or something was, or the landlord was breaking in and leaving them notes and stuff. There's some deranged stuff happens when your brain starts to run out of oxygen. That was definitely a 470. Why is it breaking the signal? I guess it's the cumulative effect of the entire filter, huh? Let's take the filter out. Our amplitude is so much better without the filter. Why? Why are you like this? Oh, wait, the 470 is on the wrong end. That's on the wrong side of the filter. Wait a minute, wait a minute, wait a minute. Yeah, these should be flipped. We were going backwards through the filter. How embarrassing. Cool. Total chaos. Just what I wanted. Why is it like sparkly? Why am I getting like transients? Okay, I need to find a different wire. This wire's been annoying me. That'll do. That'll do. That'll do, pig. So which one is output? This one. Oh, it's so loose. None of these things hold on to anything. God. Maybe we should go back to the springs. Springs knew what they were doing. Everything's ruined. Wait, what is this? Where did that come from? All right, output from the filter, kilohertz, sorry, kilo ohm, 2222, both down to ground, and then a 470 pico, which is this guy right here, down to ground. And I've never had a dirtier waveform in my life. This is obnoxious. Why is it so dirty? If I hook it up, I'm gonna hook it up a little bit more reliably. I think maybe this whole run is a little bit cursed. Now there's less pulling on the wire. It's pressing in a little bit more. Is that correct? Hold on. Yeah, it's in the right spots. Okay, so there's that. Twist these a little bit, maybe make them connect better. Do something, anything. Kill all the filters. No filters anymore. Nobody gets filters. Huh. Well, we've gone backwards. Somewhat. Mostly. Is it the op amp running away? Could the op amp be doing weird stuff? No, I think it's all just my connections are just fantastically weird. Yeah, our waveform is like super gross all of a sudden. Ah, okay, let me look back up. Fog, short-term memory loss. In extreme cases, they hallucinate and interact with hallucinations. What the hell? Interactable? So you're saying I was not in VR that one time? I'm getting noise. I'm not getting any output. Something ain't happening. So what ain't happening? Oh, my input's going to the wrong pin. There he is. Okay, there's our signal. Okay, so now putting that 470 in there does what? So now we're back to operation. It was the typical off by one pin error that plagues this kind of work. You know, you gotta look at it from every angle so you're not off by a pin. I saw this one setup that somebody had on their microscope for inspecting, where they had this whole like mirror thing that would spin around, and so they got this view from a 45-degree angle where they could spin around and look at stuff. The only other time I've seen a view like that was from an X-ray microscope that could do they could do fly around like three-dimensional views of stuff, so you could see all the bonding wires inside of a chip like going down to the substrate. It was really cool. But yeah, somebody did that with their microscope, and so it was able to do that fly around view, which is pretty functional. It's pretty useful. It's nice to have. You can really see a lot of stuff that you didn't think you would be able to see. And in this case, they were doing it so that they could see the numbers on a chip. And so you have light from one direction, and then you can see it reflecting on the laser numbers. So here's the effect of it. It's full at low frequencies, and then as we approach 9 kilohertz, we drop off more and more and more. Without the filter, we presumably get the full signal the entire time. Now I have this majorly juiced up, so typically the value would be somewhere around here. But it seems like all that's doing is just setting an offset. I guess at the lower frequencies it does do stuff. Where did that noise come from? Yeah, so you have one control on this thing, aside from the digital controls, and the one control is to turn up and down the gain on the main input stage. So I'm going to give it a 100 kilo ohm resistor, so you can get all the way from 0 to a billion in terms of turning it up and down. But if you turn off that low pass filter, you get much better. Okay, you get nothing. You get nothing. Good day to you, sir. God damn it. Come back here. Tell you to work, you work. Why have you forsaken me? In his arms forsaken me. Oh, it's because there was no input. So wait for it to start over. Nope, still same thing. Son of a bitch. Well, this is what happens when you make a wonky breadboarding setup. You gotta. This is why I don't like wonky breadboarding setups, and it's not why we've avoided it over the past couple months. But it is just something that you got to deal with these things. Is that like every single thing you neglect will come back and bite you. You just need to make sure to be vigilant about the layouts of your circuits, or you're going to end up like me, chasing down little bits that don't work. And this is why you go to like a perforated prototyping board. Or just, you know, buy the right resistors instead of the things that I got. Actually buy the right resistors. You'll have better results. I still get why I don't get anything on the output, because we had it It looked so nice before. You looked so nice in your beautiful shirt. There. Okay, something over there needed a connection. So this is without the filter, but it still has the 470. Yeah, there. And it's like, so it starts off at 0, and then I turn it up, and it becomes a waveform, but it's not centered on 0. But as soon as it crosses the threshold of the center point, no, it still goes up. It still goes up. It's weird. It feels like this is changing the offset. So the next thing that I want to test is a 2.5 volt offset going into the op amp. Now that we're a little bit more familiar with how this thing works, one of the main controls over here is turning on and off a 2.5 volt source. Now, the way Hajiwo makes that 2.5 volt source is using this infernal PWM filter thing. I think this is the prototype for the Sallen-Key bandpass filter on the VCO, but it's like, why would you make 2.5 volts this way when Zener diodes exist? In our case, we actually do have another LM whatever that I could install into the circuit because I have them. So another LM4040 B10, except this one's the LM4040 B25. The B25 creates 2.5 volts, and you hook it up to a positive 3 volts. Instead of doing all that right now, what I will do for this ground or 2.5 is I will hook up my power supply. So all I need to do is go to the 6 volt output, and I need to share the ground. Mr. Frodo, share the load. God, my friends once photoshopped me into a picture that I used to look like Samwise. So let's pull this out. We don't have any ground reference on our... Maybe we should give the op amp the benefit of not having to deal with no ground. That's like leakage through some of the internal components of the thing that's giving it... Let's turn this off for now. And I'm going to hook up... I need more leads. Where are all my leads at? I don't have ground bars. You know, I do stuff like this so infrequently that I've never needed to have like ground bars on this thing, but I do need another output over here. So let's see what I've got in the cables on the other side of the shop. Not the others, they're by the mill. By the milling machine. By the by. I should have plenty of stuff. It's just some of these are more differenter than others. These will do. These will do. So this one is one of these ones that has the 2 banana plugs at a fixed distance. And the nub is ground. Like that. And then I'll go to +6. And I have to do it with the output on. 1, 2, oh wait, what's going on here? 0. 1, 2, not 3. 1, 2, 3, 4, 5. There we go, 2.5 volts. All right, so now we got to hook this up to everybody else with these little tiny leads. Boop, 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 boop. Okay. Now I could clip it directly. I think what I'll do is I'll just I'll just take negative and I'll go in here with a wire. Let's go to minus. So now negative to negative. Well, I need to put that all the way out here where it's not going to run into stuff. These unplug very easily from this board. I think this board expects old school wires and stuff to connect to it, and so it's really not creating good connections with these sort of more modern, more thin things. More thin wires. Modern, cheap, and thin. All right, so now, see, now this one breaks off. Obnoxious. These kinds of clips are very annoying because they wear away very quickly. Okay, so now if I turn on the output, we've got a 2.5 volt offset. What the heck? No, hold on. Wait, why are we still adjusting that one? There we go. Yeah, so we're not seeing anything, but if I turn this way down... Nope, nothing. Cool. What the heck? What is this supposed to do? It's supposed to switch between 2.5 volts and ground on the reference. And right now it's at 2.5 volts. Take it off and it goes crazy. Put it to ground and things come back into perspective. Right now there is no offset volt on the input. All right, so first point of interest. We're not getting anything from our proper ground reference. So I gotta get the main circuit working first. Yeah. So nothing doing there. It's all a matter of just poking things, huh? Should be way more pronounced. Ground. Positive 3 volts. Push on everybody. Make sure everybody's still connected. So that we can actually get the performance out of this filter that we had before. For some reason now it hates me. 2.5 volts on that. Filter. Make sure everybody's placed in. Son of a bitch. This thing is tough. All of the little weirdness of our breadboard is fighting us. So I have to like jiggle this, push something in a little bit differently, poke something in a particular way, and then it'll come back to me. Doesn't appear to be helping me out at all. Bud, still with us? Hey, bud. How you doing, bud? Yeah, that should have more bandwidth to it. Okay, so there's where we were originally. Got an offset, but we're still in the millivolt range. I feel like this should be a much larger signal. Yeah, that's way too weak. Okay, none of the filter there. Bring this back over to the other side of this. Stupid low-pass filter. Yeah, we still haven't cracked a volt. I don't understand. And 3.3 volt supply here. It might just be that I'm not giving it exactly 5 to 5. I'm giving it 2.5 to 2.5, which would limit it here. I don't think I can do 5 to 5 with this. Hold on, let's see. Amplitude. It's 5 volts. I need to make it 10. 10 volts. Well, now it says it's 10 volt. We're still not getting anywhere near 3.3 volts out of this thing. Hey, I need to do something else instead of the 100K. Because, like, it's important that we use the entire bandwidth of the microcontroller, A to D. Hey, what's up, Flatulent Gunhead? How you doing? Mentioned you. Somebody here was from your stream yesterday. Yeah. Yeah, can you imagine interactive hallucinations because you have carbon monoxide? So we get a little bit more bandwidth, but we don't have the gain that I think I want out of this system. We have a 200K reference to a -10 source. If I get rid of that, this whole thing shifts. Oh, it shifts into not being able to see it. We'll put you back in. What's also kind of interesting to me is that it's not in the negatives. It's in the positive part of the spectrum. Why is it positive if this is an inverting amplifier scheme? Pretty sure this is what I built, so why is it not negative? No, that's centered and it's seeing it as positive. Very strange. Because the negative, oh, yeah, okay, the -10 is shifting it into the negatives, and then this is inverting it, so it's coming out positive. Right, okay. I even went over that during the beginning of stream, and I didn't, like, my brain did not allow me to have that, retain that information or use it at a later date. Okay, so mathematically everything is working the way that it should, except I'm seeing a weird amount of gain between it. Like, I should be seeing a 0 to 3.3 volt. That's what range we're in right now. What about this? So this thing is, wait, what the heck? Did this thing go into, hate it when they do this. There, now we're at regular numbers. You move the trigger to any of these, there we go. So 4 volts, huh? That's 6 volts. 3, 2, 1. Okay, 5 volts on the maximum there. Oh, you can't do that. You can get close. So our input is what it says it is, right? It's all the way up there at 5 volts. And what is that one coming out at? This is coming out at like almost 4. So I guess that makes sense. Well, no, this is on a different scale. Oh yeah, almost 1 volt. So it's taking 5 volts, it's turning it into almost 1 volt. And it should be centered on 1.65 and should be getting up to 3, but it's not even getting above 1.5. And I can't get the gain any higher than it is. If you cut off feedback, it goes into saturation, but I'm just turning it over to the 10K over here. Well, that was a little better. Whoa, the 10K does way more. Yeah, there's our 3 volts. Look at that. We can bounce off of the 2 ends. There's all our bandwidth. Why is there an offset? Wait a minute. Why is it offset? Hey, what the? Hold on a minute. Hey, wait a minute. What the heck? Why is it, wait a minute. Why is it like this? Yeah, that gives us, wait, but that's not doing, hold on a minute. This is doing just like an offset, it's just offsetting our signal. It's not turning up and down the gain. Whereas the 100K was? How is that even possible? How's that a thing? Why is that a thing? Wait a minute. No, that doesn't make any sense to me. It's just the timbre all over again. Oops, lost my lead. Lost my lead. Yeah, welcome to breadboarding, by the way. Breadboarding, where anything can happen. What are you guys doing today? I think what I'm... Wait, but I was observing a much better range than this on the other one. That's at a much better range. Like, I was able to lift that signal up, but that was a smaller signal. Okay, I'm starting to get an idea of what the hell's going on here. Because, yeah, that's bouncing off of the walls, wall to wall, but it's not a bandwidth. It's just sort of a center. So now what happens if we give it a 2.5 volt offset instead of ground? That's going to go into chaos. This, and then we give it reference. So with that 2.5 volt offset, it's centering it like that. What if, oh, I don't have the voltage on this thing. I can't do an offset from our input. Where's my face? I can't offset this at all because of the limits of my frequency generator. I was thinking I could offset this and do that. What is Hajigo saying should be happening here? So when 2.5 volt offset Difference in offset voltage is amplified. So with minus 2.5, it goes from that to that. With ground, it goes from there to... That, I think, is having the opposite effect because of the inverting nature of what I'm doing. So instead of driving it down, like this should be... maybe it is doing exactly what he says it is. So your waveform coming in the same way in either, it goes through the amplifier, and with ground, it's offset. Oh, but with the positive 2.5, it should be centered on... Okay, so it is the opposite. So let's flip the leads. Very simple, we just flip the leads. So now our ground is going to positive 2.5, and then 2.5 ground is going to this pin, and there it is. That's the effect that we should see. Ha ha! I'm the wiener. I ween. I am the wiener. Andor, it's me. I am the wiener. It's just we don't see the amplitude that we did with the 100K. So what's going on with that? Why can't I do a variable amount of gain? But what that's doing is that's basically correcting the offset on the outside of the thing. It gives us positive and negatives, but it shouldn't really give us negative. It gives us, I guess, down to 0. That is below 0, though. Huh. And all this is doing, this is like the timbre adjustment. I thought it would be affecting gain, but I guess it's not. Maybe I need to be putting the potentiometer in a different spot. Maybe as the reference voltage. Okay, so let's configure that real quick. We're just testing stuff here. Well, that would mean that I would put, like if I take this out and I do, need a longer lead for that. Let's use this. And then what I do instead is, instead of on the plus side, I take that to a potentiometer. So this connection, well, this connection here, instead of going there, I would put it to, oh no, this is wrong. That's not what I'm doing. Where am I? Yeah, so instead of this, I would instead go to, ground, and then this is what? I mean, that could be -10. I could go from -10 to ground on that pin and see what that does. Let's try it. So I need some leads, and I need to come up with this real quick. I'm running out of time. So one of these goes to -10, which is right there. And it goes to -10, sloppily, because we're working quickly, because it's that time of day. And this one goes to ground. I'm going to do that with a slightly shorter one. Blocked all of my lines. Oh god, this is really obnoxious. There's just stuff in the way. That one goes to ground, that one goes to -10, and then my output will then go to the floating plus comparator line. And now we have a signal there. It really didn't do anything. Whoa, wait a minute. So I have my compare. Whoa, look at that. Weird. That's a strange balance. It does appear like it uses the whole bandwidth, though. I can actually make it use the entire bandwidth of the inputs. Not that that's something that I really want to adjust for. And something has a weird capacitance in the line. It's doing a weird like voltage follower kind of thing. I don't know. Like, what am I trying to do here? Trying to replicate the Hajiwo circuit. It's just one goes from, oh, what happened there? Wait a minute. It like drops off and then pops back in. Huh. I guess that would be ground connection. And then this is oversaturated, and then it goes from there. It's like it's super oversaturated. That's ground. Saturate. Yeah, it's like it's not gonna do what is Haji was saying that it's gonna do. Where am I? Where the hell am I? On the offset voltage, amplify. On the offset voltage, offset even more. So if it's like centered, ground there, it would be offset, which is what we've observed. But then, yeah, strange. Okay, well, it's getting there, I guess. It just doesn't, it can't revolve around zero. It could, but it's supposed to amplify the signal. I don't think it did that because the 2.5 volts is treated differently on our circuit. We're not, it's not the same configuration as this. So I need to figure out how to do that with our configuration. So I think we need to get deeper into op amps. I think I need to look a little bit into this and figure out what the hell's going on. I have Wednesday to finish that filter. I really want to finish that filter off so that I have it, you know? And then we need to work on a little bit of coding for the VCO, and then I can get back to burn the subs finally, right? I think I'm done for the day. My brain's turned into mush. I got through taxes. I got through my health insurance stuff. I have to like reapply for it. And yeah, we've had a hell of a time. There's too many people home, and I've been taking up the slack, like carrying things around and cooking and doing stuff like that. I'm gonna go take my doggy for a walk. In the meantime, I'm gonna think about what I'm doing with these circuits and how we're gonna do the rest of this Hajiwo joint. I think it might benefit us the most if on Thursday, because I come back on Thursday, same bat time, same bat channel. You guys see me there. There's no question about that. But I think on Thursday, what I'd like to do is get the digital portion of this thing wired up. So we have the RP2040, the Pico Pi, and we have our analog section. So we can get those two together and see what the waveforms look like then. I'm going to turn off all my equipment, and I won't turn it on until, I don't know, I feel like doing this next. But, oh, Groovy, are you still there? I was going to show you this. I showed off the RC car at the beginning, but the Arrow actually does stuff. It's pretty crazy. But yeah, I kind of want to get that running again too, just to go crash it again. And hopefully I can find a little bit more time to do some of the side work that I typically do on these projects. But yeah, I'm trying to get this rewired again, this time with cables, like strain relief on all the wires. Because when this thing tumbles, it ejects all of this stuff into the atmosphere. But yeah, anyway, I did a whole bunch of Arrow that has little upwards curving pieces on it. So we'll catch all of that air coming into the front of the car, and we'll catch all the air on the outset. And that actually does make a difference. It holds the car down to the ground. I found that without the Arrow, when I broke it off, the car would slide a little bit more. All right. Anyway, more fun with circuits on Thursday. I want to catch you guys then. I don't know what anybody else is doing on Twitch right now. I have the channels that I follow, but you guys don't necessarily follow them. And we've had times when I've done stuff like Rated Djibouti Show, and people were like, wait, what happened? Oh, Chester's, oh, there it is. Okay, enjoy the walk. Have a good one. Well, thank you. I definitely will. I've had times where we've like Rated Djibouti Show, and people were like, oh, this is too energetic for me. And it's like, what the, like, are you, huh? Davies is going, Dahves. You guys should check him out. He's playing My Summer Car, in case you haven't seen that game yet. My crowd is a little bit different from these guys, but I do like to endorse everybody else doing some fun stuff. Yeah, not a whole lot else, just the usual crew. So I will catch you guys on Thursday. We'll come back on Thursday. We're going to do more circuit stuff. We're going to involve the digital stuff a little bit, and I think that should be pretty interesting, considering that